Okay, I think we can start. So first of all, welcome everyone. I'm really happy to be here. I'm Franco Galante. I'm an assistant professor at the Department of Computer Science at Politecnico di Torino. In my research journey, I started my PhD working on opinion dynamics. I was developing mathematical models, trying to back them up with some, let's say, more computer science analysis on data. And now I'm still working on popularity and opinion dynamics, but I also work on the use of AI in cybersecurity and some other spin-off projects about continual learning in neural networks and so on. Today, I'm very happy to introduce you some AI-based computational social science method, okay? So, first of all, welcome everyone again. And I would like to spend some minutes about a bit the expectations, which is the role of social science in, let's say, the age of AI, what to expect from today, what we will address this morning and the upcoming days, and try a little bit to frame this winter school in some sense. Okay, so what we will be doing is, first of all, why the focus of this winter school is on text. Okay, as Sumaya said, we will be looking at textual analysis. So I will give you some data, some intuition about why text is so important. And indeed, I will show you some trends about, okay, we have a lot of text. Many of our interactions, especially online, are through text. So it's important that we have ways of automatically learning from text, understanding text, okay, without just, let's say, manual interpretation or reading. What I would like to discuss also is the role of social scientists within AI, okay? And I will tell you my perspective, but maybe we can even spark a discussion, okay? So if you can tell me what you think about that, and maybe we can develop together the role, okay? And something that is crucial is that I would really like, by the end of the day, to tell you what AI exactly is, because there are a lot of misconceptions. The wide public, usually when you tell, okay, let's talk about AI, they think of generative AI, okay? ChatGPT, Gemini, Perplexity, whatever. AI is not only that, okay? AI has a long history. We will see together today a timeline of the history of AI and all the other methods that there are. And in this winter school, you will learn a lot of methods, AI methods that you can apply to text, but that are also broader. I mean, you can apply to anything. You can apply to images, you can apply to videos, speech, whatever, okay? So not the only thing, but the main thing that I want from this morning is that you walk out of this class and you have an idea of what AI is broadly, okay? We will see the evolution of textual analysis in the context of computational social science. We will see it with examples, okay? So it's not boring that I just present you a bunch of techniques and we don't really understand what's going on. I will present some examples and it's going to be a bit more fun and maybe a little bit interactive as well. And I'm going to try to tell you how computer scientists see the problem of text analysis and how they frame it. So another important message that I would like to deliver this morning is how should I organize my methodology in a, let's say, more computer science way? And how do machines make sense of text, okay? And then we will see some applications. Then I put in the slides a paper, which is pretty long. It's a recent review. I will suggest you to have a look at it. And they discuss even more in depth. I will just tell you some directions, but it's going to be interesting. So let's start. We said that we will focus on text, okay? Why? I mean, text is always been at the heart of social science, okay? Most of the things are text. Interviews, surveys, news, policy documents, archives. especially in Italy, but I think probably everywhere in the world, there is lately a huge effort in digitalizing archives, for example. We are in contact with a guy that is digitalizing an historical archive, and I mean, that's a huge effort, but all that archive is going to be textual data in a digital way, but it's going to be huge. And so having techniques that allow you to analyze, have a look at those data automatically at scale. At scale means that you have a lot of data you want to see, and you cannot just go through them. If you have millions of comments on Twitter, how can you look at them one by one? You have something that helps you. You need an assistant, okay? And I think that by the end of today, I will convince you that AI-based model, with the limitation that they have, will be your assistant. And again, apart from interview, surveys, and so on, textual data is also in social media, social platform. A lot of the interaction is through comments, through posts, okay? So text, it's vital. It's at the center of everything. It's our starting point. We gotta look at it. We gotta know how to deal with it. But yeah, really, then the question did not change, okay? I mean, the environment is changing. We get a lot of interaction, we get a lot of text, we get a lot of data we need to process, but like at the end, what we want to know is that, let's say, what's happening socially, okay, and why, giving explanation, making research questions that are valuable, okay? But indeed, the problem is volume, speed, and diversity. Because the data now is very heterogeneous. We got all types of text in different formats. I mean, it's messy. It seems difficult to deal with it. But I mean, the goal also of this school is to understand how to deal with it in a proper manner. So I told you some trends, okay? These are most about online trends, but probably even looking at, I don't know, the pursuit of digitalized document, you would see increasing trends as well. Here, for example, we have the trend of internet use, okay? So we see that it's increasing, and now we are just reaching a point in which, I mean, most of the users have access to internet, so let's say the smoothing of the function is just because, okay, we are reaching a point in which everyone is using internet. And what do people use internet for? Okay, that's also an interesting question. I would even tell you that probably that report, it's interesting. It has a lot of data, a lot of trends. I mean, when I went through it, I found it very interesting because it's like the digital report, and it's about all the figures, how people use the internet, for what, how news outlets are used for informing, and so on. But if we look at how internet is used, the first and the third place are taken, first of all, by finding information. We all use Google, now Gemini, ChatGPT, and so on, to get informations, to, I don't know, get some, let's say, research-related information to know how is the weather. I mean, we use it for basically knowing anything, okay? And how do we interact with it? Through text, okay? So there's always text. There's somebody that wrote a blog post about a topic that we are really interested in. Okay, that's text. So again, we have to understand that a lot of the interaction, a lot of the things that really matters are text. And the third use is keeping up with news. So probably, let's say, printed newspaper are not living a very good, let's say, moment, because the people are shifting towards online. And so most of the people look at their news online. And again, the online news that you see are text. So if you want to understand from a news perspective what's going on, we can look at the news there. I think that on the third day, you will be taught how to scrape and how to look at New York Times. So, I mean, that's something that is really important. And again, as I told you, all these blog posts, news outlets, online searches, whatever, most of it is text. So this is just to convince you that text is extremely important. but probably you're already convinced since you signed up for this winter school. And here there are just some other data, which I found a little bit surprising. I mean, I knew about this trend, but still, it surprised me a little bit. So this is about social platform being used as news outlets, okay? So instead of going to, I don't know, New York Times website to see what's going on in the world, okay? You use the social media to get those information. So the trend is that, like on Facebook, a lot of people declare that they get their news from the social network, okay? So that's also something to keep in mind. Again, we can, to some extent, scrape and look at the data in a social network. And if people use social network to get their news from, so probably the, let's say, the opinions, the shift in user opinions somehow maybe can be measured, can be looked at. I mean, there's an invaluable source of information there. And yeah, this is like another interesting figure. There it's like the daily open rate, so how much you open any social network, okay? The first is WhatsApp, followed by TikTok, and I mean, there the number is a little bit small, but they took November 2024, and basically users, people, over 30 days, they have been opening WhatsApp more than 25 days. And TikTok follows shortly, okay? But imagine that probably you open it even every day, okay? Or you at least pick once a day. Maybe one day you open TikTok, the day after you open Facebook, okay? So the amount of people that are using it and the frequency they are using it is huge, okay? So there is a lot of interaction, there is a lot of interesting things to see. So which are the challenges that we face in this era, especially if we consider the online environment and if we consider the amount of data, the amount of interaction, the amount of text that is produced daily? So first of all is indeed scale and speed, okay? So there are huge volume of data. I mean, news outlets, there are many news outlets. There are articles coming out every minute, okay? There are people posting, there are people making reviews. The scale is almost unimaginable. So the problem is that, can we keep up with the pace, with the speed? Everything is growing so fast. What can we do? Well, AI-based methods really come in and help you, okay? Because we will see what they do, okay? But they assist you in what you are doing. They help you finding patterns. This is an idea that I want you to get. I will repeat probably other 10 times today, so I'm pretty sure that all of you will get this idea that AI-based methods are really good at finding patterns and will help you in finding patterns. Data complexity. Okay, we have a lot of data. It's not just text, okay? Interacting, getting those data, it's not always so easy. You will learn a great deal within this winter school, but again, very complex data which are unstructured, which needs to be scraped, which are in different formats. That's a problem. But again, it's difficult to use and integrate them. But automatic methods, library, we are going to use Python. Python will help you a lot. I mean, Python, I know some of you may be a little bit scared, but by the end of today, I'm pretty sure that you will be very happy to, let's say, learn a very valuable tool, because it's so high level that helps you to deal with such complexity without even knowing it. And you will see how powerful it is. And then there are many other problems, because social constructs, let's say trust, power, sometimes are difficult to be operationalized, to be, let's say, put in terms of the data or to measure it from the data. So that's a big challenge, but that's an interesting and open problem, I would say. And then there are interdisciplinary gaps. What I really like of this winter school is that now there are computer scientists, which anyways have a little bit of social science, at least flavor, because all of us have worked either in opinion dynamics or in politics discourse and so on. But many times we look at the problem a little bit differently. But what really I envision and I hope it's going to be is that social scientists and computer scientists work together, because we see things in slightly different ways, but like putting our visions together, it's really what is needed, okay, to fill these interdisciplinary gaps, because the computational methods are really powerful, are really interesting, but they need to be used with a grain of salt, okay? So again, here we are. Let's try to, let's say, start bridging these gaps, and I hope we will be providing you with very valuable tools that you will be using in your research. So, big question, can artificial intelligence help us? Well, for sure, okay? The method that you will be learning, I hope that at least to a large fraction of you will really say, okay, I really want to learn it better. I really want to put them, those pipelines into my research. I want to use them. I think they are really important. They are really valuable. Why is it useful? How can help us? Well, first of all, scale. We said that there are huge amount of data, and we need automated way of looking at it, okay? And AI methods, programming, Python are all tools that help you dealing with data at scale. And then they help you also finding hidden patterns. I mean, all those AI-based methods, as I told you 5 minutes ago, are really good at finding patterns. And one of the things is that they will help you finding patterns, okay, into your data. Okay, but I'm scared. AI is too technical. I won't be able to do it. You don't have to think so. There are several reasons. I would say that probably even just 5 years ago, the learning curve was much steeper, okay? Because yes, Python was already there, but generative AI, for example, Gemini was not there. Those systems will help you learning, okay? Not only that, now, apart from coding being really high level means that you will see today in the Python session that basically, in some instances, if you look at the code, the Python code, you almost feel like that you are writing in English, like a really strange English that has a particular syntax, but it's so high level that you can basically tell the machine what to do, okay? We will see some examples. And another important thing is that nowadays, a lot of deal of work has been done already by somebody else. There are a lot of repositories, there are a lot of data sets, there is a lot of code already there for you. So what you need is like understanding ballpark, okay? Get an idea of the environment, get an idea of what's going on, okay? Like shift a little bit and try to see the things in a slightly different light, but then you're almost done because you can use all the things that have already been prepared for you, okay? Yeah, also I would like to mention a little bit of a misconception. So there are two things that I want to, let's say, address. First of all, okay, AI will make everything for us. Well, that's not true completely. We will see an example already this morning in which AI methods, okay, needs to be used carefully. I mean, you need to know what you're doing. And this probably is the gist of today. You need to know what you're doing. How to do it, it's simple, because already a lot of code has been done. There are systems that support you in writing the code. So the how, it's not that big of a problem, but the problem is like what you're doing, why you're doing. Those questions you can answer, okay? If you get like a high level view, you can do that. And we will be able to do that for sure. Not maybe by the end of today, but I'm pretty sure by the end of the school. So again, it's the third time. I told you that I will tell this probably 10 times today, so still 7 to go. What AI can do? Find patterns, okay? Patterns in the data. AI methods, all of them, are really good at finding these kind of patterns. And the cool thing is that they can find it for you. Instead of going through thousands of texts to find a pattern, you can have AI find those patterns for you. And another thing is that they can automate repetitive tasks. Let's imagine that you have an idea, or whatever. So you have a text and you would like to take just some words or take some part of the context, but throw away all the rest. And you would like to do it for a lot of texts. Okay, with a couple of lines of Python, you automate this thing. So you do the work once, like the intellectual work once, you understand how to do it, and then you automatize it. I mean, that's gonna be really game-changing, because that speed up your day-to-day life, your day-to-day work life, okay? And then you have time to focus on other things, on other aspects. What AI cannot do, or at least struggles to do, and probably is where you need to step in. AI cannot really define meaningful research questions, okay? That's something that you need to do, and I think you are really good at doing. So you need to define the research question. Then AI methods can help you in understanding and finding patterns. And for AI, many times it's difficult to understand social context. Again, trying to get the intuition, try to get interpret the results, the findings, that's something that you need to do. And again, this leads me to trying to see and understand what may be the role of social scientists in the age of AI. Well, AI extends, helps, supports social science, offering a tool, okay? I want you to see AI as a tool. It's going to be a tool for your research. And in red, magenta, it's like the places in which you need to step in. And if you see there, I mean, I think that only social sciences can formulate meaningful research questions. So you formulate the research question, and then you carry out, or you even can carry out your analysis together with a computer scientist. Why not? Bridging the interdisciplinary gap. And there, AI analysis helps speeding up, helps deal with scale, helps finding patterns, but then you need to interpret what you see. And there, again, you step in. And when you see the results, when you see what's going on, maybe you need to go back. You need to rethink the AI methodology. So the idea is that you are guiding AI. AI is a tool. It's like you have your toolbox, AI methods are there. But how you use it, which kind of tool you take it, it's up to you. And you do that through experience, through seeing what the results are and what's going on, trying to interpret that. Those things, you only can do it properly, okay? And then there is the validation. So all the lessons learned, do the things that we have seen make sense. Again, that's something that you can do, okay? AI will help you in finding patterns, but understanding why those patterns are valuable, which are the implications of those things, well, nobody will take it from you, okay? So the AI analysis maybe seems a bit scary at first, but it shouldn't be, okay? I really hope that already by the end of this morning, you are not that intimidated by it, but you are like, okay, I want to know more. I want to see which are the, let's say, the possibilities that AI methods bring. And so let's see briefly what to expect. I think that the main, one of the main objectives is that you will be given tools that you can use in your research, okay? So you come here, you learn a little bit of Python, you learn some methodologies, you will be given a lot of material. So even you can use directly the examples that the other expert will provide you, and you can use them already in your research. So you're going to be given tools that will help you doing your research. And all the school is organized such as being curiosity-driven, hands-on, okay? So we are going to show you examples that may say, okay, that's interesting, I want to know how it works, and try it, okay? Also later on in the Python session, we are going to code together, okay? That's the best way of learning. It's scary? No, it doesn't matter. Let's open it, let's do it together. Let's see how it works. And it's gonna be less scary, okay? So again, the idea, and there is yet another slide, is like to have these AI methods helping you, seeing them as companions, okay, in the research. A little requirement, but I'm pretty sure that you are all aware of that. For the afternoon session and also for the upcoming days, it's important to have a laptop, okay? Because again, we will be coding together, trying to do some hands-on experience. So you need a laptop and an internet connection. An internet connection you have because, I mean, I have been seeing that there's the Wi-Fi prompted there. And about the laptop, I mean, I'm pretty sure you have one, but just bring one in the afternoon. This morning, it's just gonna be me and you talking, so that's fine, but bring one for the afternoon. So, concluding the introduction, I'm gonna show you an AI-generated picture, and what this wants to communicate is that when you are in your office doing your research, you are there, you are struggling, you are trying to identify patterns, you are trying to do something valuable, you have all your research questions. I hope that you will use AI as a tool to do better research, to answer better to your questions, to speed up your research, okay? And see AI methods as tools, okay, that are there to use you, to help you. And this was, let's say, the welcome. Now I'm gonna do the introduction, but the introduction to computational textual analysis, okay? So the core of this entire winter school. So first of all, what is computational textual analysis? Okay, textual, so it is about text. We have said that text is at the heart, okay? So it's very important. We are gonna look at text. Computational means, as stated there in the slide, is that using computational methods to analyze large collection of text. I put large between parentheses because you can apply it to even small sets, okay? Large is there because usually you use it for large samples because with large sample is the only thing that you can really do. And since we are looking at text, this applies to everything basically because social media, okay, there's text. Comments, posts, captions, text. News, well, if you are reading a news piece, that's probably gonna be text, okay? Then you have interviews, policy document, historical archives. As I was telling you, there is, at least in some parts, there is this huge effort in digitalization, and all those documents are gonna be available and ready to be analyzed, okay? Through Python, AI methods, and so on. Now, let's say I would like to specify something. In the broader sense of AI, computational means AI-based. This is a little bit of a stretch, but it's just nomenclature. But the idea of this presentation is that computational means AI-based. Just because the definition itself of AI is very broad. We are going to see examples and we're going to see that in action, but for the sake of this morning, computational means AI-based, okay? Okay, but why? Why we want to do AI-based textual analysis? So, well, traditional approaches at some point reach a limit, okay? When? We know that human reading is deep, contextual, but inherently slow, okay? If you're me that I read really slowly, it's super slow. My girlfriend is super quick. She reads 10 pages when I read one. Okay, that's a bit quicker, so it scales better. But manual analysis, it's good, it's okay if you are dealing with small samples. Actually, it's even better. If you have just 10 pieces of text, probably in that case, it's better that you read them, okay? Because if even there are two of you that read those and you can discuss about that, that probably it's the ideal scenario. But if you are trying to understand what's happening on a social network, okay, you're dealing with millions of posts and comments and reaction and stuff. There's no way you can go through it, okay? The only way you can do it is like applying some methods that help you speed it up. Look at the important thing, okay? I showed you before the silly AI generated picture in which AI was holding a magnifying lens, okay? That's it. I mean, AI will help you focusing on the important things, showing you the pattern that matters, and then it's going to be up to you to understanding what those patterns really means. We talked a lot about scalability. We need to deal with scalability. Our method needs to scale. Reading manually does not scale. You can just analyze that much of information in an hour. But with these methods, in 5 minutes, if you have developed a really good pipeline, you can analyze a lot of text, okay, a lot of documents. And so indeed, as I was telling you, when the amount of text and information is so huge, the problem is not anymore getting those texts, okay? Because you will see by the scraping in day 3, you can get a lot of information. Then the problem becomes like, what should I look at? I mean, I have so much things, I'm lost. What do I do? And what AI-based methods is that they help you understanding where to focus your attention. Again, it's a magnifying lens, okay? So you need to focus there, look there. The other things don't really matter. I tell you, look there, and that probably will give you the answer that you're looking for, okay? Okay, I said a lot of times AI-based methods, okay, but what are those? I never liked timelines, okay? I found them really messy and boring when I was a student, but now I'm appreciating more the importance of timelines, because here from a Medium post, you see the evolution of AI and machine learning. And that's interesting because everyone thinks that AI is something that was born in 2022, maybe a little bit before, but before there was no AI. I mean, AI, it's really ancient, okay? It's almost 100 years old, okay? The first ideas, the idea of trying to get machines to learn dates back to 1940s, okay? And then there has been a huge evolution. You see that there is a first golden age, then a dark age, first golden age and a second dark age, and so on. I mean, it has been in waves, because every time that AI tried to develop, it arrived at some point which hit a problem, okay? So they were good at doing something, but then bad at doing something else, and so on. And I highlighted just two moments. I mean, all these moments are like cornerstones, okay? And I will not go through all of them. Actually, there are even more before and after these kind of things, but I mean, when backpropagation, it is an algorithm. It's not important what it does. It makes possible for a machine to learn somehow. I mean, that, in my view, it's really important. It's where, like, we, as computer scientists, were able to make a machine learn, okay? And then there are, 2017, the transformer. That's gonna be probably most of the, let's say, the discussion on day 5, when you're gonna really see LLMs. And transformer, it's like really a breakthrough, okay? And we are gonna briefly touch the main idea of transformer today, but those are like 2 moments that were really crucial for, let's say, having machines that understand data and learn from the data. So, as I was telling you, many times when you talk about AI, people think about generative AI. By AI, it's very broad. It's like there are a lot of techniques, there are a lot of ideas within AI. And actually a broad definition of AI is this one. Okay, so artificial intelligence is the ability of computers to perform tasks. And these tasks are usually associated with human intelligence. So we have some ingredients, we have computers. So we have machines that do some kind of things that are, let's say, meant for human reasoning. So, for example, reading a text and understanding what the text is about. Well, that's something that humans can do, right? And that's something that's associated with human intelligence. If we are able to tell a machine how to read and understand a text, okay, that's AI. Doesn't matter how we do it. It implies human intelligence to successfully complete the task. So that's AI. AI is very broad. Again, all the techniques that help you doing something that you are able to do or you should do, that's AI. But if you're able to instruct a computer to do that, oh my God, that's gonna speed your pipeline immensely, okay? So, again, elaborating on the definition of AI, computers, of course, to perform this kind of human reasoning task, they need to interact with the environment. So they need, for example, to collect data or to gather the data, okay? And then they need some kind of intelligence. We are going to see the degrees of intelligence in an example, and it's going to be really clear even the development of these intelligent algorithms, okay? And you can apply a rule, you can see a pattern and exploit that pattern in the data to, let's say, understand something on what comes next, okay? And again, AI methods have a goal, a target, a task to do. So I want to know what is this text about? Okay, I apply an AI method, maybe I will be able to tell you what is that text about. This is an example, again, coming from now a more cybersecurity related thing. I'm talking about spam filtering, but I'm pretty sure you are familiar with that because there are a lot of emails that come from fishy or strange addresses, and fortunately most of them go to the spam folder. Sometimes even good emails, legitimate email, but I mean, sometimes AI methods are wrong, okay? Not always they succeed. But that's a really good example because they are interacting with the environment, so they can, let's say, check your emails, see if something is going on, and they have a rule, so they have some kind of intelligence. They say, okay, this address, which is spam address at spam.com, may be a spam address, okay? That's a made-up name. I make it up when I was doing the slides. And they act, okay? So they can do something. They, again, can interact. They can take a decision. So, okay, this is spam. I throw it in the spam folder. But, I mean, that's very good because imagine all the people, maybe a little bit older people, that have an email account and get all these spam emails. If that filter works well, they are not exposed to all that spam, maybe phishing attempts or so. So, I mean, the implications are huge in any case, apart from the research. Okay, but this, it's gonna be interesting to discuss. Can machine be intelligent? That's a big question. I don't know how to answer, okay? I will answer at the end of, let's say, the discussion of these slides, but what does this AI model do? Okay, this AI model has some data, okay? For example, the task of this robot-like AI model is like to determine the color of some kittens, okay? Okay, so the model has some input data. So, for example, can see few little cats and knows, okay, the first one is a white cat, the second one is a dark gray one, and the other one is a gray one, okay? So somehow we make it work, okay? We are gonna say that we train it, more on that later, and at that point, the model is able to say, okay, if I see a white cat, that's a white cat. If I see a gray cat, that's a gray cat. And that's, again, some sort of intelligence, okay? But in my view, what really means a machine of being intelligent is not really an intelligent level, I mean a human level intelligence, okay? The task requires human level intelligence, but then the machine understands the pattern, okay? So if you see many white cats, you know at some point that if the color is like darker, it cannot be gray, okay? It needs to be white. So you understand that kind of pattern, okay? So all the models somehow, and we will see later, will look at the data, and from the data they are gonna see the patterns. So can a machine be intelligent? Okay, yes, if we are okay by saying that finding and looking at patterns means intelligence, okay? But it's not intelligent by itself. It looks at patterns. Probably it's going to be already the 7th time that I said that, so I just have three left. Okay, I will bother you a little bit with nomenclature, but then I'm going to go straight to an example. When I have to stop at 10:30? Sumaya? Okay, so I have 10 minutes. Maybe the example is going to be after coffee, but it's better like that. So first, let's look at some nomenclature, and then, since the example is about coffee, we are going to see it after the coffee break. I think it's perfect like that. So I told you that artificial intelligence is like something broader than, for example, language models, generative AI, and so. And there are other techniques, AI-based methods that fall within artificial intelligence but are not LLMs, okay? And those are very important. Probably in the next session, you're going to see some of those. And some, for you, are already going to be very valuable in the research because those are really powerful and are really well established, okay? Again, I told you, most of the code you're not going to need to write it. Somebody else write it for you. If you know that, I don't know, a neural network exists and you know rule to classify some Facebook posts. So, I mean, it's valuable to know that those exist as well. And then we have machine learning, okay? So machine learning is very important, and you for sure gonna use it because machine learning, first of all, is data-driven. So you need some data, okay? And you can somehow give your data to the model, and the model will understand the patterns in your data and be able to tell you something. For example, the spam filtering probably is a machine learning approach. You have some data, so you have some data that tells you, okay, the email address is this one, this is spam. The email address is another one, this is not spam. You give this table of data to your model, and the model understands which are spam and which not, okay? The more data you have, the better. So if you can see 1 million examples, you're gonna really get a gist of what a spam email is. But again, here, it's really important the quality of your data. We're gonna see an example later that will clarify this kind of concept, but machine learning are less powerful, I mean, in some sense, less powerful than deep learning models, because you need to be a little bit careful on what you give to your model, okay? The data needs to be really nice, really clean, okay? And again, you even need to know what's important. You need to say, okay, the email address is important, but I don't know, the color of the browser that the person is using, it's not important. You need to do that kind of thing yourself. But this, it's, let's say, avoided, or it's improved with neural networks, which is deep learning. Let's say that it's not really true, but when we think of deep learning, we can kind of think of neural networks, okay? Neural networks, maybe you're not familiar with, but I'm pretty sure you heard it at least once, are like some computer science model which try to mimic how the brain works, okay? So you can just think of it as like a little brain that sees the data and can perform a task
such a brain. Okay, that's more than enough for what you need. And again, it needs data. You need to give data to the model to make it understand something, and then it learns the task. So, like the spam filtering learns how to deal with the task that you are giving it, but it also learns the representation. So, probably this is a really delicate and crucial point of today, but through examples and through repeating, I'm pretty sure I will make you understand that, okay, we have a lot of data, but the core problem is having a good representation of the data. Later on, towards the end of the presentation, we are going to have a part in which I will tell you how machines, computers, make sense of textual data. Because we make sense of text because we read it. I mean, we know how to read it. Machines don't know how to read it. We have to represent the data in a good way so that the computer is able to understand it, okay? Neural networks do already something for us because you don't need to specifically define the representation, but they learn the representation itself. It's like a brain, okay? Our brain, by looking at a lot of text with our parents telling us, okay, that spells out C-A-T, it's a cat. And I mean, that process of learning is the same with a neural network. And we have read a lot until we were able to read it, but we understand the representation of the data ourselves, okay? Of course, we will see that if we help with the representation, then, I mean, the model will work better. And again, I want to stress it a lot because AI does not mean language models. Language models are a subset of AI. So large language models and language model are AI. But AI-based methods are a lot more, okay? Don't just think that it's just AI. I mean, AI is just language models, okay? It's much more. We are going to see much more, okay? So shall I start with the example, or shall we stop for a break and maybe start 5 minutes earlier?
It's okay.
Yeah, so it's 26. We are going to start 4 minutes earlier just to be on schedule. And now let's have a coffee break. And the question for let's say the later part is the coffee good? The answer needs to be yes. But anyways, the question is the coffee good? Before the break. So was the coffee good? For me, yes. I also have to admit that in my own apartment I have a Beko coffee machine that is from Turkey as far as I know, and it's amazing. And today the coffee was amazing. But we are going to take it as an example, okay? So some of you told me that, but yeah, you said a lot about representation of data, but I did not get what this representation means. I mean, I would be surprised if any of you who has not, let's say, dealt with artificial intelligence methods or Python or so on, understood what did I mean with the representation. And I developed this example exactly to give you an intuitive way of what do I mean with representation. Not only that, also making you understand which is the difference between machine learning and deep learning. Because right now, it's just two words, okay? I told you about the data, I told you about, okay, let's think about a brain that understands things, but yeah, it's not really clear. Okay, so with this example, I think you will be able to understand it, and it's fun. I mean, it's not technical at all, but it's about the idea. What I want to convey you today are like ideas. Then the technical part, I mean, yeah, you will be able to do it. It's not a big deal, okay? But the idea is understand what you're doing, that's core, okay? So let's put ourselves in a scenario in which you are a coffee expert, okay? So you exactly know what to look for in a coffee. You really like coffee, you know that the coffee needs to have that level of acidity, that color, it needs to be brewed a certain way, so you're a coffee expert, okay? And whenever you try a coffee, you focus on some characteristics of the coffee, right? Yeah, of course, you're a coffee expert, you know what to look at. So, is the coffee too bitter? Is it too acidic? Is it burnt? Which is the color of the coffee? So you ask yourself all these questions. You know what to look for. And these are what in the computer science and machine learning realm you call features. Are all the features that matter for knowing if a coffee is good or not. You look for all these things and you can understand whether the coffee is good or not, but you already know what to look for. So this is the representation. I take a coffee, I know, is it acidic, is it burned, is it too bitter, is it too, I don't know, light, and so on. So you know what to look for. That is the representation for the task, for the data that you're using for your task. The task is the coffee good or not? The representation is, how is it? Bitter, not bitter, and whatever, okay? And what you can do inside your brain, what you unconsciously do inside your brain is like you define some rules. So, I don't know, if the coffee is burned or acidic, that's bad. That's a rule. So we said before, we have features, we have characteristics, and then we need a rule. We need a sort of intelligence on it. Okay, so if the coffee is burned, then it's not good. And then if it's moderately bitter and has a dark brown color, then it's good. That's another rule. I made up those rules, so please, if you're really a coffee expert, don't be mad at me, okay? And if you have those kind of rules, then basically you have a machine learning model. Machine learning model means that you have some features that you know to look for into your data. In the past, you have been drinking coffee, so you know what to look for. You look for that and you say it's good or not good. Task, coffee is okay or not. Features, all the characteristics that you look for, and then the result is like, okay, this coffee that I'm drinking is good. Okay, so that's the representation of the data, and that's like how a machine learning model works. Okay, I skipped ahead here. It's like exactly what I said. So just to repeat, since I forgot about the slide, is like you have developed a model. Again, a model, it's a pretty general concept. Okay, when you have some input and you give some output, that's a model. So here the input is like the coffee, the output is good or not. Whatever is in the middle is your model. So in that case, the model is you. You that are a coffee expert and know what to do, you drank the coffee and you give your output, thinking of the rules that you made inside your mind, okay? You take some relevant, some important characteristics that in computer science are usually called features, and then taking into account all the coffees that you have tasted at the events, like all the coffees that you have tasted in conferences, in winter school, in summer schools, and so on, you can say whether the coffee that you drank today was good or not. So this is exactly how a machine learning model works. Okay, what about deep learning? So deep learning model, it's a bit different, okay? And I told you, deep learning usually is related to neural networks. Neural networks is like all about, let's say, mimicking how the brain works and making a machine work like a brain, okay? So the setting is completely different. Before you were a coffee expert. Now you have never tasted a coffee. So you have no idea how a coffee tastes, how a coffee is, and so on. So imagine that you can sit down and drink 1,000 coffees in the same setting. I think you will probably die if you try to do that, but for the sake of the example, let's imagine that you can sit down and drink 1,000 coffees. So you have no idea what a coffee tastes, when it's good or not good, but you try. Okay, you try the first one, the second one, and so on. You go on, and slowly you start developing, okay, this coffee, okay, this is good. The third that I drank was good. The first one I didn't like it. But you are not still aware of, okay, what was the third one good and the other one not? So you keep drinking. Of course, the coffees need to be different. If you drink 1,000 times the same coffee, then you don't learn. But imagine that you have 1,000 different coffees and you keep drinking, you're arriving to the 100th coffee that already you have an idea. Okay, the third was less bitter than the first. So maybe it's something about bitterness. You start constructing the concept of bitterness. You didn't know that, okay? You start constructing it, and that's how neural network works. They start from a random state, and then they construct a representation of the data. That's core, okay? So you developing the concept of bitterness is same as neural network understanding a representation of the data. You give the data, then there are some mechanisms that work inside, but then internally the model understands the representation. So I have to look for bitterness, I have to look for color, I have to look for acidity. Is it burned? Is not burned? To what degree? Okay? Okay? So again, no one tells you what bitterness or acidity is. You develop an intuition. I mean, going on and on and on. It's like kind of learning by doing. At the beginning, when you do something, you don't really know what you're doing, but then you keep on doing it and you start understanding better. Okay, now I drank this coffee. Okay, I understood that is a little bit burned. Okay, so you develop the idea that if coffee is burned, that's not good. So you both develop the fact that burnt coffee, not good, and also what's burned, okay, because this one was a little bit more, different from the previous one, so you work in that way. And sometimes you cannot really explain why. I put there that sentence because sometimes the representation that these neural model assume are a bit different, not always what is said interpretable, okay? Yes?
Compared with human behavior, for example, in social sciences, we have some baselines. For example, you give the example of coffee, if it is bitter and all this. So based on those 1,000 coffees you drink, you can come to the conclusion whether coffee is good or not. But how it works with deep learning machines, for example, and you are giving them like training, they learn it. There must be, in terms of social science, some baseline.
Mm-hmm. Yeah, I mean, you always start from what is called a label data set. So usually you have a group of people, a group of scientists, a group of experts, whatever, that take these data sets or part of the data sets and they look at it manually and they give a label. Probably more than one, because many times it's arbitrary. We were talking with another students before, for example, doing sentiment analysis. You may give the same piece of text to 4 different people and obtain 3 different results, okay? And so you give, for example, these 1,000 coffee to the coffee expert or the sample before, and that coffee expert says, okay, the first one is good, the second one, no, third, no, fourth one, good. So you have already what is called in computer science ground truth. So the model learns because somebody instructed him how to learn. It's not something that happens automatically. What happens automatically is the representation. I mean, internally, you don't know how the data are organized, like the concept of acidity, if it exists in the network, is learned by the model through the algorithms that make it learn, but like the input-output, you know what should be, okay? Because of that, you know that works. And what you can do then, you add those 1,000 coffees who somebody tried and labeled, but the power is that, okay, you see that your model works well. Like, for example, 98% of the time, that model tells you that a coffee is good and the coffee was good for the expert. You can use that model for a new coffee. You go to another place and you can try the same methodology that you have seen. Okay, it's reasonable, the results are good. I mean, 98% of the time, come on, I'm happy with that. And you can use that same model on a new coffee, but you don't have, again, one person to test 1,000 coffees, because that's invaluable work, but it's really expensive, time-consuming, and I mean, it's really difficult. So that's the power, using something else to train your model and then being able to have some knowledge that you can reuse over and over again, okay? And please, stop me whenever you want asking whatever question. I mean, the more interactive it is, the better it is, okay? Please.
Deep learning, it seems like it is overlapping with unsupervised machine learning in a sense that it is learning by itself without being labeled. So what makes them different?
Can you, sorry, I cannot hear you. I understood that you mentioned unsupervised learning. No, not really. I mean, what I was telling you about deep learning is still supervised learning. Supervised learning just means that you have the label, so you know that the coffee is good, given a certain coffee, and you can train the model knowing what is true. Unsupervised learning is something else that at least I will not cover today, maybe you will see the upcoming days, but it's like you have a lot of data and you don't really know what the ground truth is. So you don't know, let's say you have 1,000 coffees on your table, but you don't know which are goods and which are not. And again, there you use a representation, so it's like still some, you can do some, let's say, deep learning steps, but you, for example, group them, okay? So you build a representation, and according to the representation, you group those coffees. But you're not sure if the group that you make is like good or bad. Maybe it's just like the group of acidic one and the group of light brown ones, you know? And I mean, then with unsupervised, since you don't know the truth, you need something else to tell them apart. I mean, that's the difference, okay? Fine? Yeah, I mean, there's overlap, but I mean, what I told you is still supervised. The internal representation, all of them, I mean, also LLMs build an internal representation, okay? Unsupervised learning, it's not another category, it's within these. So it's overlap, of course, because it's like a subset, okay? So it's inside there, so that's that for sure, okay? Anything else you want to ask or know better? So, another aspect is that your judgment improves with experience. One aspect of this model is that they are data hungry, okay? So they need a lot of data to work. And that's, I mean, there's going to be a table in some slides, but deep learning models, since they need to understand these representation, it's much more difficult to develop. So, I mean, it's not enough to have 10 coffees, okay? You need to have 1,000 coffees, maybe 2,000, even better, because maybe you can capture finer patterns, more fine-grained things, and that's something that you need to keep in mind, okay? Again, these things of learning the representation, I hope it's a little bit clearer, because machine learning, you kind of give the representation, and the representation is all the characteristics that are relevant, okay? In this case, the representation is learned by itself. So, to sum up, you have developed a model, and again, the model is this process of tasting a lot of coffees, understanding which are good, which are not, and let's say deciding based on your experience, all the experience that you had drinking those coffees, and that experience allows you to understand what makes a coffee good or bad, okay? And then you can conclude on a new coffee whether it's good or bad. That's a deep learning model. This is the table that I was mentioning you. So let's see the aspects one by one, comparing machine learning versus deep learning models. So that's pretty important because we will see that one of the steps of the usual methodology is choosing the model. What should I use? I mean, there are a lot of techniques. I need to understand what should I do, but that sometimes depends on the context. So if, I mean, in machine learning, your feature design is manual. So the coffee, you need to know whether it's acidic, whether it is burn, and so on and so forth. So you already know what's important, okay? Or you can know it. I mean, you can measure it, you can derive it from the data you have. With deep learning, no, okay? So if you have some kind of data which you really don't know where to look at, you may be using deep learning, but the model is larger, okay? So in terms of the computation on your PC, it's a bit heavier, okay? Whatever it means, we probably get a better, let's say a better gist of that later on. But also, what we can understand is that the data requirements are large. Before, you already was a coffee expert. So, okay, you didn't need 1,000 coffee to understand what was good or bad. Here, you have never drunk a coffee. You needed to understand what makes a coffee good, okay? So you need a lot of data, much more data than machine learning. So sometimes you think of AI, you say, okay, deep learning, LLMs and so on, but sometimes you may need even to make a step back and say, okay, maybe for me, which I have a smaller sample, I can use a very well-defined pipeline of machine learning and that works, okay? So this is just to give you an idea of what's happening. About interpretability, it's like a research field that is active in computer science. So for example, to be able to understand why and how a model gives you a certain prediction, a certain output, is still studied by computer scientists. So it's a difficult thing. Many times a deep learning model, it's not so interpretable. While these kind of machine learnings sometimes are really interpretable because they make some internal decision, like for example, machine learning model may be if the coffee is too light, okay, so the light brown, it's not good. If it's very dark, it's good, okay? So there you know why a model made some kind of decision. Yes, but I have been talking probably 40 minutes about this machine learning, all the AI types and so on and so forth, but yeah, please.
Before we move on, I just try to understand. I understand that from deep learning you also have engineering is also involved, right? You are not simply providing the data, but also just to follow up on the previous question. So you say it's manual engineered and the other one is learned automatically. But it seems it also involves a little bit of engineering.
Yeah, I mean, all of these are really technical things, but the core, which I was mentioning you before, is that you don't know to write the code to train a neural network, okay? That's gonna be one line of code. So you have your input data, because this is supervised learning. So you have your input data, all the coffees with the characteristics, and you have your label. So you know, good, bad, good, bad, 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 good, bad, okay? You give those to the model, and there somebody has developed all the algorithm that makes it work. I mean, the two breakthroughs that I showed you before were backpropagation and transformers. Backpropagation is the algorithm that makes this possible, okay? I just want to mention it because it's a little bit more technical, but for some of you that maybe are already kind of computer science enthusiasts or have a stronger mathematical background, just look at backpropagation and you will understand why it works, okay? But then, I will show you a machine learning example without the code, because the code we are going to develop it slowly during the winter school, but that whole example is 10 lines of code, in which 4 of them, it's like, take this kind of function from the code that has been written by somebody else. So it's just like, can you please borrow me your function? And can you please borrow me your function? And you just use those. So, internally it's very complicated, but from a user perspective, it's very simple. The important thing is that in deep learning, you have this thing. You have the input, the output, and you can make the model learn. With machine learning, it's not that simple, because you have your data, and you first have to look at it and say, okay, the coffee. Doesn't really matter if it is in a cup, or made of glass, made of ceramic, or whatever. It is important the color. So you have to work a bit more on the data. You throw away the information about where it is, in which cup it is. So it's at a higher level. It's not the, let's say, the training part or the more computer science part. That is there. If you're interested, and maybe in this winter school you start like getting to, excited about those computer science topics, that's a whole field, but we will see the user perspective, okay? That's I think better for an introduction, because you gotta understand how to use it, why, which are the limitations. Those are the core things. A bit more clear? Okay.
Can you explain more about the interpretability between them?
Yeah.
Understand the differences.
Again, I will not tell you the different models, because machine learning models, there are so many. But I will mention one, which is one of the simplest, that is called decision tree. the decision tree, if one wants to think about it, is kind of the decisions on the data. So you get your data, you can read it, and you say, the color. The color is light, okay, coffee not good. The color is dark, coffee very good, okay? And the model itself works that way, okay? By looking at the data, learn these kind of simple rules, but these simple rules are interpretable, because then, I mean, if you say light or not light, and you say good and not good, you know why, okay? Because the model has seen that it's dark, so it's good. That's interpretable. With deep learning, since I told you the model constructs internally the representation, yeah, that stuff, not all the time you can have like this kind of intuitive explanations. Like it's called a latent space, okay? So the model takes the data, somehow pre-processes it, changes it, makes it in a format that understands, put in this space, and then from there it takes some decisions. There are computer scientists that are working on interpretability, and there are many ways of trying to address the problem. I'm not the first expert on that, but usually they try to make this space more associated with concepts. So if you know that in this space there is a part of this space that is related to acidity, and that part activates, like the brain, you know, when we are thinking, some part activates, some part stay silent. If you can detect that a part activates and that part is associated to acidity, okay, then you know this coffee is good or bad because the acidity part activated, but that's very tough. I mean, that's current research in computer science. So it's good to know, it's interesting to know like the ideas, but advanced topics, even for us computer scientists. Okay, so the thing was that we have seen a lot of nomenclature, we have seen a lot of machine learning, deep learning, representation, language model, okay, but I promised you that we were talking about text. Where is the text? Well, the text is the input, okay? The input of all these models is text. So I want to present you in a kind of example-oriented way the evolution of textual analysis, okay, with computational methods. And the first approaches were counting words. So imagine that you have a piece of text and you see that in that piece of text the word winning, championship, trophy appears a lot. So you may think that, okay, I see a lot of trophy, champion, maybe they are talking about sports. Makes sense, right? So you are counting words in the text and you say, okay, if I found championships on, or probably they are talking about sports and not talking about astronomy, right? That can make sense. And that can be considered, I mean, borderline, as an artificial intelligence approach. Because still you're making, okay, a simple thing, but you're making the machine read the text, count the words, and then based on those counters, you can say, okay, this text is about something or is about something else. Then you have dictionary or rule-based models, okay? What does it mean? Okay, for example, I see championship. Yeah, but championship may be used also in other, or trophy. Trophy may be used also in other contexts. So I give trophy a score of 2, but I give player a score of 3, or championship a score of 5. So you define rules yourself in which you give different weights to different words. It's a little bit more complicated, right? Because you gotta, you know, put some effort trying to be aware of the context and try to develop some rules that make your machine understand, okay? And that's still an artificial intelligence approach. Then we have the machine learning. So there I put trained models, machine learning models, and deep learning models. We have seen those. I mean, we have been talking about those for 20 minutes. I will show you an example without the code, but as I promised you, the code is 10 lines, 9 lines even. So the crucial thing that I want you to understand and to learn is that oh, my battery is getting low, and that's a problem. Sorry, 1 second. Does not work? Okay. So, give me 1 moment. Huh? Okay. Usually it shuts down when the battery is so low, so let's hope that it will not happen. Don't buy gaming PCs, especially if you're not a gamer. The battery does not last. Thank you so much. Oh, okay, thank you so much. Perfect. Okay, we can resume without the PC shutting down. So there is the machine learning part, and of course it evolved this way. So first you started counting the occurrences of words, then you started developing more intelligent and sophisticated rules, and then you say, okay, but now we have machine and deep learning, why not using it in textual analysis as well? So we are going to make some example there as well. And then we have, I put deep learning that is overlapping a bit because there I put deep learning, so it's just a representation of that. But then we also have LLMs. Okay, we have language models and large language models. Okay, today we are gonna just get a very, very high level understanding of that. But like day 4 and day 5 are gonna be all about LLMs, language model, and so on. So just to get introduced to that, so this classification that I told you was twofold. First of all, understanding that AI-based methods are not just generative AI. That's like a part that came 3-4 years ago, but there's like a almost 100 years old story about AI, and there are a lot of methods that work really well, and then you may use into your pipelines, okay? Yeah, but it's a bit boring, right? Okay, the rule-based model, counting words, okay, they're not so clear. So what I want you to do is that read this text and tell me what it is about. So 2 volunteers, the first one that raised their hands, otherwise I ask my colleagues to do that, and tell me what this text is about, and you can choose from these 4 high-level topics, okay? So we are going to try to make some examples on text classification. You have 25% chance of getting it right anyways, and if you don't get it right, better, because we are going to see that there are techniques that fail, and there are techniques that, can do this task. Any of you, one of you that tells me in her or his opinion, what is this thing about? Okay, please.
I think computer graphics.
Okay, that's the right answer. But this particular example, I was a little bit a bad person because I highlighted planet orbiting, okay? This is like, okay, this image is copyrighted, so already the start, it's telling you that, okay, probably it's about something graphical, it's images, so on and so forth. But then you have a planet orbiting, you have a picture of the Earth. It can deceive a machine, okay? Machines are, I told you, are intelligent in the sense that they learn patterns, but sometimes they learn the wrong pattern. The pattern may be, if I say planet orbiting, how can it be related to computer science? It's a pattern.
I wanted to choose space.
Okay, thank you. Even though he's my colleague, we didn't agree on this, so you can trust him. And this one, I took a data set, I developed the pipelines that I will not show you, I will just do a high-level eagle eye view, but I choose this example because this was deceiving many methods, okay? Because when you're counting words, for example, orbit, I mean, orbit is something related to space. So you can get deceived. And indeed, okay, just a nomenclature note, sometimes I will use labels, sometimes I will use classes. What it really means is just the topic, okay? I don't want to confuse you. Label, classes, topic, in this setting it's all the same. So computer graphics is a label in the sense that given a text, you put that label on it, but it's also a class because if you consider the 4 classes, that's one of the 4 classes, okay? Just a nomenclature note. So, what I want to do is show you the evolution of AI methods by looking at the performance and by looking at the ideas behind the various methods, okay? Instead of giving you another timeline with a lot of names, a lot of marks and dates, let's do something more hands-on, more interactive in some way. So let's try to understand which are the ideas behind each approach. And of course, we start by counting words. So the idea is that, okay, if I see how frequently some word appear in my text, and I have an idea of the words that usually appear, so sports, okay, if I know that ball appears a lot, because I have some text, I read it, maybe myself, I told you, these kind of models, sometimes you need to label them yourself. So you read some text and you see, okay, all the text about sports have like a lot of time the word ball occurring, or disc or ice. This dataset was about hockey. I put it sports just to be general, but actually is hockey. And if you get that, you know that, okay, probably if I have another piece of text and I see ball, disc, and so on and so forth occurring a lot, maybe that piece of text is about sport, okay? So you learn from the data in the sense that you read some data or somebody has done that for you. And then for each class, we have sport, computer graphics, I don't remember, space, and another one, politics, okay? For each class, you count the words in the text that you have, and you make a score. So the word, I don't know, government in the politics class appears a lot, okay? So maybe you can have an idea, that's an index that word tells me about that text is talking about politics. But the problem is that in this case, if I used a frequency approach, it fails in terms of sports. That's pretty strange. Like, why sport? Well, here I did the interpretability for you. Slightly, in the classes, you had more texts about sports than all the other classes. So you had a bias in the data, okay? That bias in the data make you say sports whenever you're not sure. So if the words don't tell you, yeah, this piece of text is a bit difficult, I don't really understand if it's about computer graphics or about astronomy and so on, I tell you sport because I don't know, it's the most occurring one, so the probability is higher there. I mean, but it's completely wrong. I mean, this does not make sense. Okay, it's wrong by far because, okay, you can be confused about astronomy, science, and computer graphics, but you cannot tell me sport. Okay, so knowing this, that is failing brutally, what kind of performance do we expect on some text? Well, pretty low performance, okay? Question, did I do the most intelligent thing that I could do? Well, no. These kind of algorithms can be tweaked a little bit, so you can try to better, let's say, at some point you have to stop counting, okay, because you may have thousands of words, so you count just the top 100 more important, the top 50, but all the rest you throw it away, you lose a lot of information. So there are always these kind of trade-offs. Here the trade-offs is not that smart, okay, but it's a simple approach, it's one of the first, and yeah, if you do it smartly, maybe you can even get something better. But this naive approach has a lot of weaknesses because it has a bias. I mean, bias in the data is something that you always need to be aware of because here you had more sports text than any other. That bias may affect the output of your model. And then, as I was telling you, you discard infrequent but possibly informative words. So, I don't know, if you discard nebula, because, you can keep counting, but even on machines, you cannot have like very, very long information about counting all the possible words that can occur. At some point, you need to trim that. You throw it away and you say, okay, I focus on what I think it's important. Yeah, but maybe if nebula appears just once in your texts, okay, that's astronomy. Okay, you're sure about that, maybe. But it's more likely that it's going to be like that. And you are discarding that. So, again, can we do better than that? Already, if we are not discarding those words and so giving a bit more complex representation of the data, this number rises a little bit. But let's try to do something better in terms of methodology. I told you that the second thing that has been tried and, historically developed is rule-based approaches. And as I was telling you, such a rule-based approach,
Just to close the voice, you will just switch off and on the lights and it will close.
Did I have to do something?
No, just you can continue.
Okay. I was telling you that in one of my first projects, I was not really an expert of machine learning and deep learning. I was like more on the mathematical side, mathematical modeling, but I had some data and I needed to label them, okay? So I needed to do something that we are doing, like what is this about, okay? And what I did is this kind of rule-based. I needed to tweak it a little bit. Again, here I just make a non-optimized approach and we'll see that the performance are going to be so-so. But this is still valuable. If you really know what is important in your data, so one word occurring, you can make a rule. If that word is occurring, then it's about this thing. That's a really valuable approach. And it's automatic, it scales. Your knowledge of social scientists with a lot of experience, it's put into a programming language that recognizes the pattern that you tell the machine to recognize very quickly. It can really save your time, it can really speed up your workflow. So again, these words, these important words, may even be found by inspection. So you have this text, you take 100 samples, you read them carefully, you understand by class which are the important words, you understand how the context works, and you say, okay, this one is really important. I give a score of 10. So that means that if I see that, probably I will tell that class. This one happens here and there. So maybe I give 2 and 2, a lower score, but still, that's something automatic that you can do. So again, about sports, if I see ball, match, winning, okay, those are all related to sports. Maybe I can give a score to them. If I see them, I can probably say that what's coming next is sports. And of course, you can assign the scores. So according to your experience, according to sensibility, you may define a different score. The idea is like to define simple rules. So if this word appears, then I give a certain score. Okay, so it's pretty simple. The rules that we were mentioning before that the model need to have. Okay, in this case, you tell the rule. Okay. So what happens in this case? We have seen that the true label is computer graphics, but here this approach tells you space. Okay, it's still wrong, but it's a little bit more plausible. I'm happy that this approach failed in this way because before, he was telling me sports. See, yes?
I didn't clearly understand why are we trying to code them as 10, 9, 8? Your previous slide we were talking about you give the score of 10, you give the score of 8. What is the purpose of giving the score there?
It's importance, right? It's about importance. Imagine that this is a very naive example and does not apply in reality, but imagine the words the, the. Yeah, that word will appear in any text. You should give the score 0. It's not important. The word ball, it's used maybe more in a sport context, so I should give a higher score. This is still arbitrary, but this is the development. We start from counting. We go to hard coding, putting ourselves the rules there, and we go to machine and deep learning that they know how to define the rule. It's like just a flow. Instead of, the goal of this part of the slides is like not to bother you by telling you, yes, we started by counting, then the rule-based approach came, then we did machine. It's like, okay, start with a text. Let's do the simplest thing that comes in our mind. Let's count, okay? And then, yes, but probably if I give scores, which are arbitrary, okay, so, it's still a method, maybe not the best one, but still work in some cases. I told you I used it myself long ago. Let's give some scores based on our experience. So ball is more important than the, or it's more important than is, you know? So score 0 to some words, score high to other. And you can weight, okay? So ball is more important than winning, because you can win, a grant, okay? So that's science, that's not anymore, you give different weights, but ball, okay, if you have science as a possibility, yeah, maybe if you are a physicist, ball can be relevant, but again, depends on the context. You can weight it yourself according to what you see, okay? So still wrong, but plausible. Which performance do we expect? I did it in a way in which performance are growing over time, but because also these are finer and smarter method in some sense. So here, considering some text, okay, many text, and applying this idea, these rules on this text, okay, we get 60% of accuracy. That means that we got the right topic 60% of the time. Well, it's not ideal, but it's not that bad. We just put some rules, like if you find this word, then do this. If you find another word, it's really simple, and already that's done automatically with you can do automatically with Python, few lines of code, and you have already something that, okay, it's reasonable. It's not that bad. So just adding sensible rules, we got a big improvement. We almost double, okay, because before we were around 30%. Now we are around 60%, okay? Of course, there's a lot of maintenance, and this is tough to do, because if you need to define the rules yourself, you have to read, you have to look, think, understand, then maybe you put one weight, but it's really arbitrary, you should have put a higher weight, your friend does the same thing, and instead of putting 8, puts 9, messy, okay? Very high maintenance, very basic pattern matching. Okay, again, you're just giving a score. It's like counting, but giving a score now. So the question is always the same. Can we do better? Of course, the answer is yes. And we go to trained machine learning model. Trained means, as we said before, that they learn from the data. So you have some data that some really good person labeled, so put like, okay, this coffee is good, this coffee is not good. They took the time to do that. That's an invaluable effort. You have that, and you can use a machine learning pipeline, a deep learning pipeline, to get a model that can tell you if a new coffee is good, okay? So the idea, here it's a little bit more difficult, but at least the high level idea, I think at this point you can get it, because it's all about a smart representation. Before we were just counting words. Here, let's try, I will not tell you the details, because day 4 is all about this, and I will, in maybe 10 slides, tell you some of the ideas that will help you in day 4 in understanding well. It's all about the representation. If you have your data, and you give a good representation, and then you use a model, that is SVM is a model. There are many. Before I told you about the decision tree, don't be scared. There are many, and all of them are implemented. We, computer scientists, have almost never implemented a model. Those are there. You need to know why to use one and how they work, but you never have to write the code yourself to make them work. Somebody, really good people have done that, and you can use that as a tool. Are all tools in your toolbox, okay? So again, this smart representation is TF, IDF, and it doesn't matter. It can be called whatever. Just keep in your mind that it's a smart representation that goes beyond word counting. Before we were saying ball appears once, twice, 3 times, so on. Here it's something more difficult. You will see it, okay? So it's all about, okay, I have my data, I should also put them in a reasonable representation for the machine to learn. Then the decision, of course, the internal representation is learned as well, but if you help the model, it works best, right? I mean, if you have a really small text that you cannot see, you won't be able to read it. If you have a nicely formatted and nicely printed text, you can read it easily. So again, here, it's the same thing, okay? Good representation with a good model, good results.
What does SVM and ITF-IDF stand for?
TF-IDF, it's a long acronym that is...
It's term frequency / inverse document frequency.
Okay, yeah, and... Huh?
It will become clear in the next.
All these will supported vector machine. It's, again, all those are like algorithms. Covering algorithms is not the purpose of this introduction. It's just to know that there are techniques, many of them. I mean, probably none of us knows all of them, but according to what you're doing, you can say, okay, I have this kind of, you frame the problem, and when you have framed the problem, you can say, you can search for the tool that better fits your need, okay? And you will see tools in the summer school, okay? So the winter school. So some of these, TF-IDF, you will cover it. SVM, probably not, but you will see other models, and that's fine. I mean, whatever model doesn't, the really important thing is that don't focus on the model, don't get scared on the specific type of model. Get the idea. There are tools, there are models that work well. You can use them. Also because many times, as a computer scientist, you don't know if one model works best than the other, because it depends on things that go beyond our, comprehension sometimes. So what usually computer science do is like, okay, I know that there are these 5 models. I know the first 3 very well, but the last 2, yeah, I know they exist, but I don't know really well. I mean, I don't know the details. Let's try all 5. Somebody implemented them, so I apply them. And then I see which one work best. So it's important that you don't, let's say, overthink the method. The methods are there to be used. Think a lot about the context. What is the problem? What you're going to solve? How to frame it? And then how to interpret what you get from it, okay? So this, it's like... Again, it's a method that can understands how to separate classes. So the idea of this method is that it's able, in a space, you imagine that you have these texts as points in the space, in this room, okay? What this model can do is that, okay, if a text is there, then I can say, okay, that's sports, okay? If a text is here, okay, that's computer graphics. Okay, I know that it's a bit a crazy idea, it's not very good to grasp, but let's imagine that that model can just separate the texts, okay? Like you have all the text on your table, and that model comes and is able to sort them out, okay? And so that, okay, I know that this in top right corner, it's all the sports. In this top bottom, it's all the astronomy, and so on and so forth. That's just start building an intuition, yes?
I want to be sure about one thing. This table is about which AI uses techniques, right? Is this right? Like AI follows these steps to give us an answer.
No. The steps that AI follows gonna come in 3-4 slides. This is the evolution, okay? So you start by, these are 4 different methods, okay? This is like the naive, we have already seen, like you count words in the text and you say something. Okay, throw it away. All the thing that was done in the past. We go to rules. We have a rule that says, okay, if I see ball, I give ball a higher score because it's more important than the other. Okay, that's another one. Now, we have talked a lot about machine learning model, deep learning models, how they are smart in learning the representation, and so this is another method. All these are AI. This is AI, that is AI, that is AI, and then we are going to see an example with LLMs. That is again AI.
Like a chronological, right?
Chronological. This is chronological. In very few slides, I tell you the steps within each method, because then, again, the internals of the method are, difficult, arbitrarily difficult, but the ideas, then there are 4 steps. We are going to see all of those, okay? Are you still with me a little bit? Okay, so yeah, this is just a spoiler. I mean, this approach that I know is super complicated, I know that I confused you a lot. I wanted to put that spoiler because at this point I was expecting people throwing fruit at me because it's like, now what is this, what is that? I was aware of that, but you know, I needed to show a little bit of the complexity, but I wanted to tell you, yeah, it's tough, it seems tough, but it's not that tough. If you know what you're doing, how to do, it's easy. I mean, it's 10 lines of code in which 4 of those lines are like, hey, borrow me this function, hey, borrow me this function, hey, borrow me this function. It's like that. It's gonna be like that. I mean, it's not so intimidating anymore. When I was a student and I was doing like, they made us programming in binary. I mean, zeros and one. That was scary. That's not any longer needed. That's not Python. It's almost English. We're gonna see it this afternoon. Okay. So just want to tell you, this is gonna be very, very quick and easy. Okay. And this time, we got the label correct. Okay. So this time with this method, which is still abstract, you don't understand. Maybe it seems strange. Okay. The model got it right. We got a correct classification. And this is a simple but robust method, okay? So which kind of performance do we expect from this third approach? Well, yeah, it performed well on the text we have just seen, so good. It is around 92% of accuracy. That means that on 100 text that you provide this model, 92 times you got it correctly. And 92 seems, okay, but I want 100, right? Why don't I have 100? Well, I want to make some reflection, because imagine if you give those texts to 100 people. Do you expect that all those all those people agree 100% on those on the classes? We did something like that. We had a data set and we had 3 people looking at each of the text individually, and I don't know, there were many texts. They did that. The agreement was not 100%. That means that also, decision, even for human, we don't agree 100% of the time. But having a tool that 92% of the time tells you something that is reasonable, it's very good. If you match that with something that tells you how far are you, if you have a way of saying, if you can target the 10% and leave behind the 90%, okay, you reduced by a lot the sample that you need to look at. Then at the 10% you can look at it, okay? That maybe makes sense, but the 90% you have it there. It's something I think really powerful. I really hope that this sparks you some curiosity in saying, I want to know more. I want to try it, okay? And why it's that? Probably this is going to be the second to last time that I tell you about representation. And why this works better? Because you have a better representation of the data. So if instead of having very small font, different font from one line to the other, you have a really nice text with very big font, you can read it well. So the representation is good. And here is the same. If you can put your data in a nice representation, then your model will learn better. And the second thing is that the model understands itself what matters. Okay, so think of the magnifying lens. I know that is a AI-generated image that I showed you, but think of that. You have the AI methods that are your magnifying lens. They tell you where to focus, and the methods know themselves where to focus, so they understand automatically what's important. This is the concept of training, okay? Training a neural network, training a machine learning model, training a model. Training just means you learn from the data. You have data, you understand it. It's like our training. You are here, I'm speaking, I provide you information, you store that information and you elaborate it. That's training, same thing. The models use a lot of data to train, to understand, okay? Yes?
Again, when we say training, I think we mean that we build more algorithms. It's not just feeding data, but it's also like giving some complex algorithm to learn from the data. I think we're missing this point maybe, because just feeding data to the system it's not going to make it learn. I just want to understand this.
Yeah, you are training from data.
Yeah, I see. But again, what is learning from data? How the system doesn't have intelligence unless we give it rules, let's say, or algorithms.
Okay, so I probably go long, but I will take 5 minutes to try to understand at a high level to these questions and give you a hint on neural networks. Okay, so neural network is one of these models. It's a deep learning model. And as I told you, you have your data, which have the data themselves and what they represent. So you have the coffees, all the stuff about the coffees, and you have the label, good or not good, okay? So imagine imagine it as a black box, okay? You cannot see inside. Inside, imagine that there is a brain. I mean, all the neural networks are made up by neurons. So you can perfectly find at this stage thinking of, okay, I have a box in which I have a brain, okay? And you take a coffee, you know already if it is good or not, okay? And you make the coffee go through this box. And your model, your neural network tells you, okay, I know this coffee is good, but the neural network tells you it's not good. So you take your bet and you slam it on the box, okay? That slamming is like the algorithm that makes the box learn, okay? So inside something changes, okay? Just think about that. It's like that. The mathematics is tough. I will not tell you that, but if you look at the backpropagation, you will understand the mathematics behind. But imagine that you slam it and you change something. So you take another coffee. This coffee is bad. You make it pass through the network, the model, and the model tells you, no, I think it's good. You slam it again. Something changes inside, and you keep doing it for 1,000 coffee. At the end, you arrive, okay, this is a good coffee. I put it through my model, and the model knows, but okay, this is a good coffee. Now you understood it. You do with a bad coffee, yeah, this is a bad coffee. And then the model, from the data, has learned the patterns, okay? Just think of, slamming it repeatedly. Because what you are doing is that you have some parameters, some numbers inside the model, and you change those parameters. Okay, so you make it, okay, I have this value, I make it a bit higher, I make it a bit lower, and of course there are rules, there is an algorithm, the backpropagation algorithm that does that. Okay? I'll go on. Maybe, okay. So we are to the last example, last approach in practice, and I wanted to do something that is not the smartest way of doing it, okay? But I wanted to do it that way to highlight you a kind of problem. One of the previous slides was like, AI will do everything for us. We can sit back and let it do the magic. Here, I'm gonna use LLM in a way that is called zero shot. That means I have the model that somebody else has trained on something, and I take it out of the box without giving it context. So I don't do anything. I take it and I use it. How does it work? It's plug and play, very nice. So somebody else did that. It's like GPT-like, okay? I put there kind of GPT do it for me. So you take your task and you say, okay, you are an LLM, you know everything. Do this task for me, okay? The task is still text classification. So I give you texts. Doesn't matter how, just do it, okay? It's super fast to set up because you don't have to do anything. You just say, please, you write it like in ChatGPT, please, can you classify the following text? You put the text in one of these 4 categories, and the model determines which class fits best, okay? Well, with this approach, we got a really bad, not a really bad, but quite a bad result. And again, I did not the most intelligent thing I could do, but this is just to push you to think that it's important that you understand what you are doing. I cannot think that AI will do anything. So, okay, I just plug and play. I ask GPT to label all my data. I don't think about that. No. You need to know which are your goals, which are the condition, the context, And then, informed by that, you can choose the methodology, helped maybe by a computer science. Interdisciplinary efforts are amazing, and then you can use your methods and models. Because here, for example, you need to define the labels. Okay, giving a definition is not that easy. How can I define sport? If I tell you, okay, sport is all about, all the things that are about hockey are sports and so on. Again, I put all those biases, all those problems, and this was to make you reflect that, okay, I need to be careful. I can use it, it's very powerful, but I need to know what it's doing. So all your comments that you have been doing are true. So the thing is that you need to know what you're doing and use AI with a grain of salt, okay? So if you know that, which is your problem and how you can frame it, then you can use it. Don't use it just like that without knowing what you're doing. And yeah, another problem, more technical, is that this kind of approach is very slow. The other, where like you throw the text, you get the output. Here, it takes some time, okay? If you have many examples, it takes hours of time. And the performance really depends on the model size. So if you ask ChatGPT, for example, you take ChatGPT, you put the text that I showed you before about the computer graphics in orbital stuff, and you ask ChatGPT to tell you how is this about. If it's a newer model, probably it will tell you, okay, this is about computer graphics applied to astronomy, okay? And we will get slowly an intuition on why language model performs so well. But again, here we didn't have such a large model, and so the performances really depend on model size. So there are a few setbacks also in this case, and you have 2 days that basically you are covering pre-LLMs and LLMs, so you will probably know more than me by the end of those days. And this, again, is to give you an idea of why LLM can do what they are doing, okay? Because for me, when ChatGPT was like the far front. Now there are many models, but when LLMs came, I was a bit puzzled of how good they were, because as computer scientists, we know that, yeah, I told you that training a model, you do it in 10 lines, but to get good performances, you need to try a couple of times. It's not that easy, okay? And usually you get something that is good at one task. When I saw that, this kind of model could do anything, I was a bit puzzled. How is it even possible? One of the keys is that these kind of models are trained with all the knowledge. Okay, so imagine the internet. If you feed a model the internet and the model is large enough to understand the patterns there, you understand language. You don't understand, you find the patterns in language. So you get a representation of the language, you basically can speak. You know things, okay? And you build a statistical representation of the language. So our models that really know, if I'm speaking what's coming next, I can tell you, I continue. We are talking about machine learning, I can go on. That's something incredible. But yeah, we just had very bad performance. We said that LLMs are amazing. Yeah, I told you, depends a lot on the size and how we are using it. Don't think that all the problems can be solved by asking Gemini, okay, or ChatGPT. Advanced stuff, let's keep it. If you do something more sensible, you can use language models to do very good stuff, okay? And you will learn it, okay, day 4 and day 5, probably day 5, and that's gonna be very interesting. Okay, this is like for when I share the slides, you have a summary of all the methods that we have seen. But since we are a bit short on time, I will wrap up the benefits of AI-based methods. In general, we have seen 4: counting words, rule-based, machine and deep learning, and LLMs. And which are the benefits of all of these? So, first of all, scale. Okay, well, we may have a lot of text, a lot of interactions. If we see online, I work with social networks. Now, sometimes it's not about the data availability, sometimes yes, but sometimes it's really about where should I focus. Sometimes I may need some methods that tell me you need to focus there. You need to put your attention, your methodology, your expertise in some place. And this trend is increasing. I mean, I was seeing a trend on blog posts. I mean, blog posts are increasing month by month, week by week, and so on. There's a huge quantity of information out there, and it's difficult to keep up if we don't have some, let's say, methods, some tools that help us doing that. AI-based model can do multi-language analysis. That's really cool. I mean, sometimes you are constrained, I may be constrained by the language that I speak, but this kind of tool can translate pretty well. You can go like beyond the barriers of languages. That's something that's really interesting. And you can focus more on the questions, on the problems, okay? So you can really develop important social relevant questions and focus on that. Because, I mean, I was discussing before with one of you, AI-based models don't work all the time. But you know that even when you look at a question or an interview, or some responses are easy, maybe easy, okay? Because it's, I mean, when you look at it, it's clear. What if you have a method that can help you filter out those, and just the difficult one, the divisive one, the biased one, you can focus on that. So you put things, okay, these are the easy ones. I can use AI to classify those. And these ones, which are the challenging ones, those that need an expert to say something on, I can look at it. Like having a tool that tells you where to focus. That's something that AI AI-based methods can give to you. And yeah, time efficiency. I mean, imagine hypothesis testing. It happened to me many times, and I would assume also to some of you that you have an idea or you think something, you develop a methodology, you develop a data collection and everything, and it takes months of your work, and then you arrive at some very non-conclusive results. Well, that's a setback, right? If you have something that can speed up some of your process, that's going to be a very good tool that you can use. And if maybe you can just use as a hypothesis testing. So you have an idea, you do some AI methodology to see if that makes sense or not. And then you do your own usual pipeline to have robust results. There's a lot of ways in which you can use these kind of tools, and all of those are pretty important and pretty interesting. So probably I will not be able to finish, but doesn't matter. I will take 40 minutes maybe in the second part, but I will start telling you about pipelines. I think I will take 15 minutes. Can you bear with me a little bit more than it was scheduled? Because as we had a question before, we saw methodologies, but we didn't see really inside what's happening. It's not clear at all. So I started this slide with a bit confusing so far, and it may be. It's okay. It's okay that that what I have told you, it's like a bit confusing and not so clear, because so far I told you how. I didn't tell you how the models, the methodologies that I introduced you really work, okay? And now I would like to tell you about the methodology, because all these methods follow a simple pattern, okay? It's like a kind of 4-step pattern. And I want also to touch something. This probably we are going to do it later on when we come back from lunch, and we are going to discuss a little bit on how do machines make sense of data. And this is really about the question that I've been asked a little bit before, because you need to develop some way to measure stuff and have smart representation for your data to instruct the machine to do something, okay? So this is the 4-step approach. And the good and interesting thing is that basically we are gonna kind of follow this thing in the next days, because you are gonna do with Andrea data collection. So you go out there, you collect your data, you know what is meaningful, you know what is interesting for your research, and you scrape the web. You do whatever you need to take your data. Then those data, it's important that you work on those, you pre-process it, okay? Because data usually, especially coming from online platforms or taking them online, are dirty. They have a lot of stuff that, you need to filter out, you need to make, again, a good representation of what you have. Then there is model design. We have seen some models in actions. All those rule-based ML and so on were models, okay? We saw them in action, but that is like the third step. When you have your data, when you have make some sense of your data, then you can start choosing, okay, this is important, I should use this model, this other one, and so on and so forth. And then there is model evaluation, which is a two-stage process, and we are going to see it why. So data collection, you can use your digital collected data. You have whatever source of data, you are an historian, and you have an archive of documents. Okay, that's a good starting point. You don't need really to collect data if you have those in digital form. You may use some textual computational analysis to be performed on your data. Or you can scrape data, like taking it from the web. That's going to be day 3. It's going to be all about it. And there's a lot of publicly available data sets. So there are already a lot of data online that has been collected, maybe even labeled by people, and you can I mean, are there to use by the community, so you can use those. And this is like your starting point. You have your raw initial data, okay? The next step is data pre-processing. And this is particularly important. Sometimes it's neglected, at least by computer scientists. We are sometimes a bit sloppy. It's like, okay, we get the data set, let's try to put the methods over it. We rush sometimes, but this is arguably one of the most important steps, because for example, text have a lot of stuff. Maybe they have URLs, special characters, emoticons that may be relevant or not depending on the context. I mean, you just need to be aware of your data, okay? Because one of the usual saying in machine learning, in AI in general, is that if you put garbage in your model, you get garbage out, okay? So you see here, if you have noisy data, bad labels, if you have biases there, okay, as we were discussing before, your model learns what you're telling the model to learn, okay? So this part about curation, about knowing how your data looks like, how it is, which kind of problem have your data, it's very important. It's super important, because then the model, if you have a bias in the data set, your model will have that bias, okay? So this is crucial. Remember that. If you put garbage in your model, you will get garbage out of your model. And I mean, I will go quick, because you will do this on day 4. It's all going to be about what to do, why you should do it, and so on. But a typical pre-processing for text, maybe you need to clean your data. So maybe remove the URL and stuff like that. Try to make your text more uniform. So you have capital letters, lowercase letter, and so maybe you make everything lowercase. You can do a lot of, let's say, cleaning things. And you may deal with stop words. We were saying before in the example of rule-based, in which maybe they are not so informative. I mean, are really common words. I can have a they in a sports piece of text, but also in a computer graphics one. So maybe, are those meaningful? Should I keep them or not? And then you can do something more advanced. Again, day 4. But sometimes you want to simplify things, so you have running, maybe you want to transform it in just run, okay? Just run, maybe it can be enough, it's a simpler representation for your model. A little warning, models are very good at finding pattern, but most of the time they are lazy, okay? I mean, I'm lazy as well. Probably many of you are lazy, but I don't want to offend anyone, so I'm just gonna tell that I'm lazy. And if I see a shortcut, I will probably take the shortcut. Models are like that. And this is all about the bias thing. If in the data you have a bias, probably the model will first look at the bias and take the shortcut and say, okay, I will take it. That's it. I'm not gonna spend any effort on that. So data curation, data preprocessing, avoiding biases, I mean, that's really important. Otherwise, you may have a model that just learn bias, and you don't want that. So we are at the third step, which is model design. We have seen 4 models, so 4 approaches already at a very high level, so it's not clear how they work, but somehow this is where some magic happens, okay? But what you can do is that, what you need to do is that you need to choose the model family. We were discussing before why SVM, what is it? There are a lot of models, but first you just need to know that they exist, and there are many, and there are some that are more suitable in some situation than others. That's what you need to know. And so maybe sometimes rule-based models for your textual analysis are perfect because are quick. You can set them up, are interpretable, and so sometimes you need to do deep learning stuff. But that depends, that's something that comes a little bit later, okay? For example, keep in mind data availability. We said that deep learning models, you need 1,000 coffees to drink before you will, let's say, grasp which coffee is good, okay? So if you need a lot of data to train a deep learning model, keep that in mind. And I will just mention it, but we will see it at the beginning of the first section. I told you it's very important to prepare your data. So I will skip the next 3 slides, but I will resume from there when we start again later, okay? Because that's really important. But I have been speaking for 1 hour and a half, so I think you are tired. And this is so important that I want to tell you later, okay? When we have had a coffee, some lunch and so on. But I will just tell you about sorry, we will come back later. I will just tell you about this, okay? The last point. So at least we have seen the typical 4-step ML pipeline methodology, okay? The last one, it's like a model evaluation. The first stage is kind of more technical in some sense. It's more like, does the model work? For example, we have seen the frequency-based approach. It had terrible performances, okay? So do I want to use a model that just 35 times out of 100 tells me the correct thing? No, okay, I need to develop something more sensible. I have to rethink my methodology, change the model. I take another model, I'll try if another model works best. And this is more like a technical thing, okay? Then there is probably the most important stage, is like results interpretation. So I got this analysis, I got like some methods that told me where to look at things, where to focus, but does it make sense? Which kind of narrative, which kind of implication do these observations have? This probably is the most important stage. And according to this, you may even want to redesign your project, your methodology, because maybe you find a bias in the data. Maybe a computer scientist does not see a bias in the data, say, oh, okay, 98%, it's amazing, I publish it in a very good conference. But maybe a computer scientist, does it make sense? No, there's a problem. Find the bias, correct the bias, and does a stronger, more robust thing. That's a very important step, and that's probably where you may give an invaluable contribution. So there's going to be something about applications, but we will take 30 minutes, even 20 at the beginning of the next Python session, and then we will start with Python. But tomorrow it's going to be an entire Python day, so we have enough time for coding, okay? I'm going to talk a little bit later, and I will see you probably in 1 hour. And questions, whatever? Yeah, sure. Even though I will probably take away some of the time from Python, I think these things that are pretty important, okay? Because we have seen different models in actions, some ideas behind those. We have seen the evolution of these models in time, and we more or less understood that each machine learning pipeline consists of first step. So data acquisition, data pre-processing, model design, and result validation. But something that is still not clear, or at least just at a very high level, is like I told you about these representations, but how can machines make sense of data? Traditionally, social scientists use qualitative method and statistical approaches to tackle this issue. But how can a machine develop this kind of experience, this kind of sensibility? Is it even possible? Well, of course, computers, machines, algorithms, whatever, do not understand, okay, the meaning like humans. You cannot just give text to a machine or show like a sheet of paper. But what machines do is like they take the text, they break it into patterns, whatever it means. A pattern may be the frequency-based pattern that we were mentioning before. And then they put together stuff that are similar. So winning team appear usually together, so I group them together and I provide a summary, so those things are together, so maybe they are related to sports. And so what it's really important is that machines need a numerical summary. Okay, so at some point we need to go from text to whatever kind of numerical representation. So now we are going to do a kind of excursus on the different numerical representation that are out there, and in the following days you will have a better understanding of that. Now it's like just really high level idea to start, making what does it mean numerical representation of text, but then you're going to really put your hands on the code or on the concepts themselves to try to develop, understand better, and so on. So let's start from the simplest, let's say, method to represent text with numbers, and it's basically what we have already done, because the key idea, okay, computers need numerical representation, and what is called bag of words is nothing else that a kind of counter. We already did something similar, because you have all your texts, and from that you extract a vocabulary, so all the words that have been used in that text. And you have all your words. For example, if you have a really small vocabulary, just 4 words, 1, 2, 3, you take those words, and then what you do is that you count. You count how many times those words appear. So for example, if in your document word 1 has appeared twice, okay, you put a 2 there. Word 2 has never appeared, okay, you put a 0, and so on and so forth. You're just counting words, okay? So I told you about all these kind of methods and so on, but at the end, the first step is always counting, okay? There are a bunch of problems with this kind of approach. Maybe I didn't highlight them strongly before, but I want to reason about that with you now, because you lose word order, okay? So maybe in a sentence, word 2 comes before word 1. Yeah, but that may be a crucial piece of information that you lose. You lose meaning, you lose context, because you're just counting, you're not doing something very deep. And so imagine that you have a sentence like, movie is good. It should have been the movie is good, but I didn't want to put too many blocks there. And so imagine that your dictionary is movie, is good, and then not, okay, because your dictionary may contain even the negation, okay? And so you do this kind of bag of words approach, and you count, okay, movie appears once, is appear once, good appear once, not appear 0 times. Yeah, but then if you have movie is not good, okay, you have the representation that tells you that not appear once, but you don't have something that tells you, okay, that not is related to good, okay? So you lose meaning, you lose context. That is a problem. It works if you need to classify sports and, computer graphics, because maybe the vocabulary are sufficiently different enough from one another and it may go well. But sometimes it's problematic. I mean, this representation does not link not to good. That's a problem, okay? So we should improve that a little bit, try to get, let's say, a wider meaning from the words that we are assigning to our words, our text. And one of the intermediate steps before LLMs is like seeing words as vectors. Okay, what is a vector? You can think of a vector as, usually in physics they show you a vector as an arrow, okay? It can be in multiple dimensions, that's gonna be a bit more difficult to think of, but just think of, you have this axis and you have a point there. You have a arrow pointing somewhere, okay? That's a vector. And so maybe you're able to provide a vector for Apple. Okay, it's not very clear what does it mean to have an arrow pointing somewhere that, let's say, encodes Apple. I will make you an example that makes it clearer, but this kind of representation is possible, it's numerical and is understood by the computer. The key idea is that the geometry, okay, tells you some information about your words. So, to have a simpler and more intuitive understanding, let's divide this room in two, okay? So, the front row may have a meaning, okay? You can encode whatever meaning you want. So, the front row is the row of people wearing particularly type of jacket because it's colder. I don't know, it's just made up. Huh? But this geometry, this space assumes a meaning, okay? And that's what we wanted to encode. We missed in the bag of word representation the meaning. So now, where your vector is pointing, when your vector is at, as in the geometry, a meaning itself. I know that this kind of concept, it's maybe a little bit difficult to digest, but I just want you to think a little bit about it, okay? Because later on, this kind of representation is going to be important, and it's one of the bases of what you will be doing at day 4. But you may ask, why we want to do something like that? So what we want to do is that maybe if we are good enough in developing this kind of representation, we may have similar words that in this space are close together. So imagine this toy example, okay? This dimension maybe tells you how much animal a word is. Whatever that means, it's just a concept. You just have to develop the idea. While this direction tells you the fruitiness of a word, okay? Whatever that means, okay? Just imagine that in terms of abstract concepts. So if you are able to do something like that, you will hope to see that banana and apple are close together in this space. So because there is the fruitiness, an elephant is not very fruity, okay? But there is how much something is related to the animal world, and okay, an elephant is an animal, but the important thing is that there, in that space, in that geometrical area, you have words that are together, and there you have a far away word, okay? So that's something that we struggle a little bit to understand, right? It's a bit abstract. Why are we doing such crazy things? Well, this is the type of the representation that really works with computers. If you have to tell what is a text, what is the meaning, which are the relationship of words and so, you need to have such kind of representation. You will be able to see it. Again, think of the fact that I always told you that neural models and some kind of models learn the representation themselves, okay? So imagine that somebody is able to tell you that that direction has a certain meaning, okay? So just keep this in mind for the upcoming days. Try to think a little bit about that. We can even discuss, but this is pretty important. And there's a further step that really changed it all, because there, okay, you had the words, you have some words that, okay, you may have apple as a word, okay? We were talking about fruits. Okay, if you try to use that representation, okay, apple, it's gonna be close to ananas, pineapple, it's gonna be close to peach and so on and so forth. But what if I'm talking about the company? I mean, the context is important. The context is vital. You cannot just take words, count them out of nowhere, and not reasoning, not considering the context, okay? Because the first sentence here, apple is sweet. Of course, we are talking about the fruit. We can understand that we are talking about the fruit because, I mean, the company can be sweet, maybe not. I mean, the context here is suggesting us, okay, apple is sweet, that's a fruit. But Apple released a new device. This word, in that context, refers to something completely different. And what the representation of before was lacking was the context. And here is where the breakthrough happened, transformers, okay? You're going to have a look at it, but what they really do is like they are able to represent words in their context. This is the only idea that you need to keep in mind, okay? Not only the single word, counting it without considering the context, but the word in the context. So each vector now, you have seen before we had this representation with these arrows. Now the vector moves, shifts according to the context in which it is, okay? So let's see a not really technical example. Just think here, like good, it's more linked to not than with the other words, okay? So you have to really, the transformer need really to capture the fact that movie is not good, is not and good are related, but good is also related to movie that is related to not. I mean, the sentences are in their context. This is pretty magical because what transformers do a pretty smart way is like taking the words in context, and that's what makes all those LLMs, all those language model work, okay? So this is the core thing, okay? You have your text, you gotta have a numerical representation. You have a bunch of ways to do a numerical representation, but when transformer came, they not only let's say, give you a good representation of the words, but they give you a representation of the words in context. And that's, if you get this kind of idea, by today you are already halfway through. And of course, being able to do such things, they can capture long-range dependency, because it's, it really relates one word with another. So even if you are saying a complex sentence and a word is related to something that comes really far away from that word, that still can capture that kind of relationship, and that's pretty amazing. Of course, this is the state of the art, so the best you can do in language understanding. Okay, we have already seen it. I'll go through applications and just few minutes, because I will point to a good review that I read about the applications that is pretty recent, I think from 2025, and then we will start looking at Python, okay? So I put there the paper from which I took this picture and some of the content on the slides, and we have seen text and topic classification, right? Because we had a text, I made you the example, okay, what is this about? And of course, that is one of the possible use of AI-based models. But then you can do sentiment analysis, okay? So try to understand, let's say, try to quantify the sentiment of some pieces of text. You can do hate speech, stance and humor detection. You can apply to misinformation. All these fields can benefit from AI, of course. But all of these are really specific. Like, for example, I've been working on social network analysis because I've been using data from social network and what's going on, something about opinion dynamics. But then, probably some of you are experts in some other fields, and in all of them you can apply the ideas that we are trying to develop in this winter school. And okay, that's I guess something that I told you already many times. And what, again, from the article, I will probably just mention this part. That's something pretty cool that some people, even some of the experts, are doing, is that you have generative models, so they can, generate text, they respond to text. It's like, GPT, you give a prompt, you write something, and it answers. What if we use these models to simulate let's say a human interaction, right? There are people that are working on that. I don't know how difficult it is, because I mean, apart from reading it from papers, I never tried it, but there are people that are trying to make, let's say, a simulation of the human interaction. And all these things are possible because of what AI brings on the table. And so, just, you know, last slide about this introductory part is that we have seen that LLMs do not solve all possible problems, okay? LLMs are not the only technique. We have seen deep learning techniques, machine learning techniques. There's a lot on the table, okay? And probably after this week, you will be more aware about the tools. You may understand how to use some of them, but the important thing is that you know what is out there and what you can use for your own research. I mean, you can really do something sophisticated. You can use these LLMs. We have just said that LLMs are able to capture the context, so you can go deeper, okay? So you can use them to better understand the context, better understand what it's like in some texts. There are reasoning models, so they even are able to reason over text, over things, over concepts, okay? And something that I really want to mention, and we touched somehow with some of your questions, is that they have multimodal capabilities. So it's not just about text, okay? In general, machine deep learning model, LLMs, can interact with anything, okay? So speech, images, videos, okay? The basic ideas, those of having a representation, giving the good representation to the model, all those things that I told you about text, in this case, apply for any kind of source, okay? For images, for speech, for whatever. So don't think that you are restrained to text. You can use these kind of methods for anything, okay? Let's just start by text, because that, I mean, it's already a very important and very well studied field, and so let's first develop it, and then you can use it for anything, literally, okay? So yeah, this would have been the slide that I wanted to show you before the lunch break, but I couldn't make it, sorry about that. And I hoped that after the introduction, I mean, I hope all of you, but at least many of you are considering maybe just to give it a try, not necessarily use them, you know, thoroughly for everything, but try to use AI-based model to, you know, put them in their research, see how far they can help them and so on. So I really hope that you changed a little bit the perspective. Maybe some of you already wanted that. Maybe some of you were a little bit hesitant. I hope that those that were hesitant are a little bit more interested, at least to give it a try. So let's do this week, we give it a try. Maybe it's gonna be valuable, maybe not, but let's try it. So I really hope I sparked that in you. And after that, we need to start coding together, okay? I will tell you some basic things about Colab, okay? Which is the environment that we will be using. I will use slides for about 20 minutes still, because I want to tell you something about the environment. I want to tell you some basic about programming. I mean, in my mind, anyone today can understand what we are doing, because I start from zero, okay? So don't feel discouraged, don't feel scared about anything. We start from the zero level and we build up, okay? And in some minutes, we will be opening together. I mean, I will be opening a Google Colab environment with you, and I will teach you, and I will program together with you, okay? There are gonna be even some exercises, some stuff, and I really want you to try to do them. And, as always, whenever you feel that you are not understanding something, you have a question, you are stuck, raise your hand, and I'll help I'll provide you all the guidance that I can, okay? Okay, so I ask you to try to open your PC, to go to Colab and create a new notebook, okay? Then I told you I will still use some slides, so you're gonna have the time to open it, to have a look about it. I will explain like the various things, because at first it may seem a little bit, I don't know, confusing, but try to go to Colab, click on the link, and open a new notebook. So Google Colab, okay? I'm gonna do it with you. It's the best way of doing it. So you Google it, I even made a mistake in spelling Google, so very bad on me. And then you click on the first thing and you see what I was showing you, okay? So there is this open a notebook thing. And from now on, I will switch again to the slides and you can go through. Okay, I need to do again extend. I'm gonna keep the changes. And I'm gonna, okay, so you have been prompted that, and just click on new notebook, okay? And it should, I mean, you should go to a new page that should look like this one. Of course, you're gonna be probably untitled name there, okay? But I put a name. So there is like the notebook name. What is a notebook? Well, this is a notebook. The notebook is the environment that we will be using. The cool thing about notebook is that that's really handy. I mean, you can write code, you can write comments, you can do a lot of things, and it's interactive. Then I think there is also a slide on what is a notebook. A notebook is an interactive environment that is there for you. I mean, to computer scientist student, we spend probably the first hour of lecture telling about how the compiler works, which are the environment, the dependency. I mean, they struggle, but here it's a safe environment, it's a safe place. It's already set up for you. What you just need to do is like, you see there, start code or generate with AI. That means that you don't even really have to code yourself if you trust it. We are gonna code together. We are gonna see how AI can help you, but today we are gonna try to code together just for the first time to get an idea. But there you write your code and you execute your code. So you give instructions to the machine and then you say, okay, now do what I asked you to do. We are gonna go step by step to do that, okay? And there is an integration with Gemini, okay? I don't know if all of you have, but for example, I have even the auto-completion. We will see later on what does it mean. But I mean, AI is integrated in this environment. So whenever you feel lost, just click there and ask, okay? That's an help. For today, ask me, okay, please. But in general, you have a companion already there. Okay, I put there a link to a tutorial. When I need to learn like a new environment or a new thing, I always go on YouTube. And in general, also I was discussing with some of you, for the concepts, like I mentioned many times a transformer. There's some really good videos about transformers, okay? So just go on YouTube and try to have a look. There are a lot of computer scientists that are passionate about making videos like that. Try to have a look there. So, I was telling you, what is a notebook? Notebook is what we have just seen. It's an interactive environment. So you can, I mean, interactive meaning you can type things, you can execute, you can do stuff with it. I will do those together with you, so no problem with that. We go, let's say, step by step, but it's important that you understand that in the same environment you have your code, so all the instruction that you provide to the machine, you have text, meaning comments, whatever you want to see. You will see that the thing that I prepare for you usually contains some explanation in plain text, okay? And then there is the code, which we will try and discuss and run together, okay? And you got also the results in the same place. This is very nice because in one place you have everything you need. You have the code, you can make comments, you can put pictures. I'm gonna have some pictures even inside the notebook. And how to use it? Well, I told you there is this block in which it's written start coding, and you just put there whatever you need, okay? And if I did it well, yeah, try to do like this, okay? So with the hashtag, okay, with the hashtag you make comments, okay? So it just, hashtag means, please computer, I want to input something, ignore it, okay? But then it's gonna be your, maybe for some of you, the very first line of code. So just do like this, write exactly what I wrote. So print, open parentheses, double quote, today I will learn Python, double quote, close parentheses. I want all of you to do it, okay, please.
There's a space after the hashtag.
Yes, but it doesn't matter because that's after the hashtag. After the hashtag, everything is like ignore it. Okay. So just, I mean. What you should see is that after you wrote that line and you pressed that play button, what it happens on the output part is today I will learn Python. Okay? Did you manage to do it? Did you already run? Yeah?
It's just continue. I don't know. It didn't finish. I mean.
No, you need to wait a little bit maybe. The first time it needs to do. Yeah, it will. It's syntax. It's like the comma. The comma in natural. Yes. No. That it's like, you know, because sometimes coding it's a bit difficult. I mean, you make things that even you have to think a bit, and you write there something to say, okay, I did this, I did that, and did that. Okay. Yeah. It's like your comments. Did all of you manage to do it? Does somebody want to have some assistance? There are very good computer scientists that are walking around, so they will for sure tell you what to do and what's going wrong, okay? So please don't be scared. It's really important that you do this first step. After this one, it's everything gonna be easy, okay? It's like the first time that you press the button and you say, oh my God, what's happening? But now, it's gonna be easy. We're gonna learn a lot together, okay? So I think I can understand from the silence that there is in the room now that you managed it. Thank you for trying, and let's go on from now. I will still give you some slides because I promised you. Let's start from the ground zero, but then I will move to your same collab environment and we will work together the concepts, some specific things of Python, and we will try to code them together, okay? So let's see, in practice you have already done, so let's go on. Gentle introduction to Python. So let's start from 0000. So what is Python? First of all, that's the beautiful logo of Python. Probably you have already seen it, but I always liked it. And okay, it's a programming language. What is a programming language? It's like any other language, just is meant for machines. So it has a syntax, it has rules. Of course, since it needs to go inside a machine, it has stricter rules, okay? Because us as humans are a little bit more flexible. I mean, we can understand each other even if we make some mistakes. My English is not perfect at all, but still you can understand me, right? But machines are a little bit more picky. If you don't write print properly and you write print, then the machine will not understand you. So that's something that is bothering, but you know, in few times that you see those strange red errors, and then you get used to it. That first time that you run your code, probably it's going to be problematic.
People try to write print with a capital letter, and that doesn't work as well, because
Yeah.
Python is stupid. Like, computers are stupid, and you need them to be...
Most of the programming languages are case sensitive. So if you write, for example, if you write something in capital letters and something in lowercase, and those are two different things. So really, machines are really strict. So it's a language for strict people, okay, for strict things, okay. But a good thing about Python is that very similar to English. I mean, there are where the parentheses, the hashtags, something confusing, but you wanted to print something, and to do that, you just wrote print. I assure you, if you want to do that in C or in C++, it's not going to be like that. It's super confusing. Already to write your first line of C++ or C, which are other older programming languages, and that's take just one class just to try that, okay? So Python is much better. And why do we need it? So again, compared to C++, Java, others programming language, Python is much easier, okay? Like the learning curve, of course, the first impact is always scary. Like any new things that you try, first time you may be scared or at least a bit worried. But Python, it's so high level, it's so, I mean, it's driven by ideas, by almost English words that you will learn very quickly. And is the basis of most ML AI approaches. I told you that somebody already wrote the code that you need for you. And these people usually wrote the code in Python, okay? So that's pretty important. You have already a lot of resources, a lot of libraries, function, all that you need, it's already there. You just need to a little bit understand the environment, start getting used to maybe using Python a bit, not being scared any longer, and then, I mean, it's downhill from there, okay? And you will see that even today probably we will, and tomorrow for sure, tomorrow it's going to be a Python day, you will see how powerful it is. Like with one line you can build an histogram, okay? You can build a data distribution to see your data. Everything is very easy, it's very intuitive, okay? And before coding together, I told you we will be coding together, but before I just want to be sure to, let's say, set up a little bit the jargon, because like as computer scientists, many times we are in our bubble and we use terms that are not really accessible. Like I'm talking about variables maybe. Well, what is a variable? I mean, maybe I know, maybe not. And then I use execution of a code. I already used that, so my bad. But I want to, you know, start thinking a little bit more like a computer scientist in some way, but giving you the basic lexicon, the basic dictionary for I mean, speaking with each other. So I already made an example about coffee, and I know that I'm not very creative, but I'm gonna make another example with coffee. So you're gonna know me as the coffee guy after this winter school, and it's totally fine. So this time, instead of understanding whether the coffee is good or not, like the function of before, we are going to prepare a coffee, okay? It's not going to be, let's say, the best coffee, okay? But let's try to prepare a coffee, even if you just had one, okay? This is like kind of not so bad timing because I just had a coffee, and I think even some of you. Okay, so let's think at a really high level. Today it's like high level reasoning. What we need to prepare a coffee. I'm gonna do it like the more Italian way. I don't know if all of you have ever used a mocha, but the mocha is that thing there. And what you need is like, you need water, okay, that's sensible. You need coffee. There are the grains, but you need coffee powder. And yeah, once you have your mocha, you can take a certain amount of water, a certain amount of coffee, you put them in the mocha, put it on the stove, and then wait. You're gonna have your coffee. So this is an algorithm, okay? So whenever they tell you or speak about algorithm that seems some very strange, they go, what is an algorithm? No, an algorithm is a procedure. So you do one thing, you take water, you take coffee, you put water and coffee in the device, in the mocha, you put it on the stove, and you're gonna have the coffee after a while, okay? That's a procedure. Computers are really strict. I told you, they are not so flexible, especially when you're trying to talk with them, okay? You need to be very precise. So we need to go a little bit more technical. We need to start thinking how the computer will be able to understand what I need to do, what I want the computer to do. This is an abstract example, but it's pretty inspiring, I would say. Because, okay, let's say that I need 100 milliliters of water, okay? And then I need 20 grams of ground coffee, okay? These are variables. A variables is something that, okay, sometimes maybe I need 120 milliliters, some other times I need 10 milliliters. That's something, I mean, that changes, that holds a value that you can specify. So that's your variable. Another variable is the quantity of coffee. Sometimes you want a stronger coffee, so you put 25 grams. Sometimes, like my mother, she likes a lighter coffee, so I would put 15. Okay, so those are variables. And then there is another crucial aspect, a crucial concept that I want you to think about, is that function. The mocha serves a function. The function of the mocha is that given the inputs, so given the coffee and the water, produces the coffee. The function of the mocha is making a coffee. How is a function different from doing any machine learning task that we have seen? A function is something that has a purpose, that does something, okay? So here you take your water, you take your coffee, you put them inside of the mocha, and you get the coffee, okay? So now this is not really gonna be code. It's not really gonna work in Python if you try to write it down, but it's instructive, okay? It's the lexicon that I will use, the syntax, is gonna be Python syntax, but for the coffee example. So the first line is from the kitchen and the drawer in the kitchen, import the mocha. That means that hey, you need the mocha, you don't have it. You go to the kitchen, you take from your cupboard the mocha, and then you have the function. That is something that you're gonna use all the time in Python. I told you, somebody else already wrote the function for you. Somebody else already bought the mocha and you have it in your drawer. Just take it, okay? So import mocha means take function. So now you have the mocha. So you can do the coffee, but what you are missing the ingredients. So, I mean, as I was telling you, likely somebody already wrote the function for you. Somebody already bought the mocha and put it in the drawer. Yeah, you need the variables. I mean, yeah, you cannot make a coffee without water and without coffee. This is a variable assignment. So you want water, okay? So you say, I want water. How much water do you want? Water needs to be 100 milliliters. Okay, so water equals 100. That means that your variable, your water variable, has the number 100 in it. That's it. Then you want to do the same thing with coffee. Ground coffee equals 20. You know, I used again the comments. We already seen in the first Python, I will learn Python today thing, that you can put comments like that, because sometimes it's important, you know, there you say 100 watt, 100 millimeters. It's more for you, because the machine doesn't care, okay? You need to put the correct amount there. And we have a function, we have not used the function yet. Okay, you want to make a coffee at the end. So you take your function, that is the mocha, you provide water and ground coffee, those are the input to a function, and then somebody wrote the mocha function. You don't have to think, yeah, but the mocha is really complicated. You don't do that in the real life as well. I mean, I don't know really how a mocha works. I take the mocha and I use the mocha. Python is gonna be the same. You take the function, you use the function, that's gonna be it. It's difficult a little bit to speak this machine-like language, but you know, since it's a language that is similar to English, at some point you're gonna be proficient. So it's just like the barrier of speaking the language. When you destroy that barrier, it's gonna be downhill. You have a tool that is invaluable in your hands. And so this is a function. I mean, I will stress again what a function is, because talked about model, function, everything is a little bit complicated. Well, everything is the same. A model is as well a function. I told you each model has a task. A model needs to do something. I want a machine learning model that classifies text. Okay? The function of that model is text classification. You're going to have a function which has always some input, one or more, coffee and water, ground coffee and water, and it has one or more outputs, the coffee. So it's like that, and the syntax is very simple. It's name of the function, open parentheses, and your inputs, close parentheses. That's it. And each function implements a certain type of task. Okay, as I was telling you, this makes coding easy because you can define your own function. You will arrive at some point, maybe even during this winter school, in which you, okay, I trust others, but I want to, let's say, I want to define my own function. You can do it, but at the beginning, it's better to use somebody else's function, okay? Just use what is there. Try to get familiar with the tools. And when you are confident enough, then you can do whatever you want, okay? This one, pandas, okay, the name maybe does not give away what it's about, but it's all about tables. If you have tabular data, that makes very easy to deal with tabular data. You will see that in one line, we can make averages over all the columns. And doesn't matter how big is your data, okay? So it's really powerful, but as I was telling you, just try to get to know the syntax of Python, the language, try to get into the language, and then everything is already there for you, okay? There to use. I think this is gonna be, okay, just 2 slides. We are gonna see it again in action, so it's gonna be clearer, but still I need to say something about this kind of boring technical details, because when we are going to see those in action, it's going to be clearer, but a number, you need to represent it somehow, okay? So the number 1 is an integer value, okay? So you have to tell, I mean, you have to know that an integer number is a little bit different from a string, which is text, okay? So there are a lot of types. We will see them while we are coding. It's much easier. You can do, of course, operation on that, but I told you these programming languages, the machines just understand numbers. So you have to somehow define these numbers. I'm gonna skip this one because I want with you to start writing some code, writing some examples. So let's do this way. I still have time. Okay, I still have time. So I'm gonna open a Colab notebook. Let's do the same, all of you. I'll show you some theory and examples together. We are gonna try to cover some things. It's gonna need to be a little bit interactive. So if you have questions, if you are stuck, if you don't feel like it's clear, just stop me. Raise your hand, stop me, and I'll tell you more, okay? So just give me 1 second. Okay. Big enough? Too big? Okay?
It's okay.
So, we already done our first line of Python code ever. For some of you, some other know already, but this thing is like to set your mind of, okay, today we will be learning Python. It's not gonna be maybe the easiest thing of today, but we have already done quite a deal of work today, so let's not stop here. So, introduction to Python. I will introduce all the basic concepts, try to make you understand that the data needs to be organized a certain way. We are gonna see how to do that, why, and so on. Try to make some examples. There are gonna be some exercises, okay? just try to do them, okay? So I will speak for a while, I will show you stuff, you can even write, I mean you can copy, for example, while I'm speaking you can start, I don't know, writing those things that I wrote there, but then we arrive at a point in which exercise, and you need to do the exercise. I'm gonna show you the solution after, I don't know, 10 minutes, 5 minutes, 15 minutes, whatever the amount of time you need, but it's really important that you follow me, that you try to understand me, you ask me if you need something, and then you try it yourself, okay? If you do that, yes? And more than that, then I cannot see what I wrote, so. Okay, so.
How do we create, how do we add a new cell of...
Okay, thank you so much, Giordano. So, I wrote some code, you had already a cell there, how to add another one. So let's say you want to write another print statement. So you have here a plus and code. You just press it, okay? And that's it. You have another kind of star coding thing, and you can do, for example, print. Okay, we can do it together. I mean, this is a print statement in another cell. Again, you press the play, and you see that there, this is a print in another cell. Okay, so it is as simple as that. Let's imagine that I found something very insightful. I mean, I'm scared that I will forget about it. That happens to me. I don't know if also to you, but sometimes I have a good idea and then after 5 minutes, if I don't write it down, it's lost forever. So you have a way of writing it down. So you add text, you have this plus and then text, and here you can write whatever you want. Okay, I'm gonna make a lot of syntax mistakes and typos and so please bear with me. But there, you know, now you have something written in plain text. You can do very complicated things. We are gonna see how to structure the data, and you will see that I had put some pictures within these text things. And it's nice because when you're dealing with data visualization, it's like you have your data, you do a lot of things, but then you want to visualize what you have been doing. You can make plots and see them. So you can even share this with your colleagues. So imagine that you are working with somebody. You write your code, okay, so you have all your methodological part there. You get some results, you have them there. You can send all the notebook, okay, to your colleagues, and they see both what you have done coding-wise and all your results. And even you can put there, you know, all the notes. If you are like me, that after 1 week you forgot which type of methodology you thought about, you can write detailed whatever equations, whatever consideration you want. It's all there, okay? So, I will show you one thing. I don't know if all of you have the auto-completion on. What do I mean by auto-completion? Let's see if it's on or not. Okay, then I will show you, no, don't worry. But like, for example, I want to print hello. Look, do you see there? I mean, I know that I'm a bit in the way, yeah? Sorry about that, but you see there, Gemini knows already what I want to do, because, I mean, I helped Gemini, I said I want to print hello, but Gemini knows already. So you can press tab, and you will be able to print hello. So, I mean, there's this auto-completion function that is gonna be, I mean, it has been a game changer for us, computer scientists, because now we don't have to think too much. The syntax we have seen before. Why do I have to use this crazy syntax that is so complicated? Yeah, because machines are strict, but with these kind of things, it's gonna be much easier, okay? But, just for today, I suggest you to disable it, okay? Not necessary for all the time. Let's do like this. Let's go to Tools, Settings, okay? Then in Settings, you have all these things. You go to AI Assistance, and you switch show AI-powered inline completions. It's like completion of your code. Switch it off, okay? And then close. In this way, it's going to be much more difficult, but then, if you're struggling, just go back and try to enable it, because otherwise it's too easy. I mean, literally, you start writing, and already, since we are doing basic things, today we are just dealing with, okay, let's take some numbers, make the sum, look at some very easy tabular data. I mean, those things are pieces of cake for Gemini, okay? For us, it's gonna be a piece of cake, but we need some time, okay? So disable it. If you are in trouble, either ask or enable it again. To enable it again, you just go again to Tools, Settings, AI Assistance, and you flag that again, okay? So, okay, this is a must. I had it on the slides, but it's better that we try together as well. So, I will code with you. I have there still some stuff that I already wrote. You see that there are already the details and the outputs there. But we're going to do everything from scratch together because it's instructive. So imagine you want to write down an integer number. So like 1, okay, or 10. So you do, okay, like that. You give it a name, whatever you want. I mean, that's a label to your value. So it's like the coffee before, right? It's more sensible to call the coffee coffee instead of writing A, B, C, D, right? You can do it as well, but always use names that make sense. So you have integer number and you assign a value. For example, we said we want 10, okay? Maybe you want to print that value. So we have seen that, like, to print stuff, we just have to write down print. So we do print and we do integer. That is not the autocompletion of Gemini, okay? That is the environment that tells you, okay, I know that you in the past already wrote integer number, you may want to use it in the future, okay? So it's just, something that helps you. You can ignore it for the time being, you will use it a lot when you are more familiar with everything. And so you can do like this, and I mean, it's there. You have defined a variable which holds the value 10, and you print its value. You may do even something more complicated if you want. So let's imagine that 10 is the the cost of a coffee. Probably not the case, but I mean, if you go in Venice in the best square ever and you get a coffee there, maybe $10 even. Okay, so the cost of a coffee. Okay. You write this between those quotes, yeah, thank you so much, quotation mark, and then you put a comma to say, okay, that's one piece, then I want you to write another piece, so the other piece, it's like your variable, and so you press the play, and okay, the cost of a coffee, colon, 10. Okay, and yes.
How do we decide on which parts to put a quotation mark or not? So we put a quotation mark on the cost of coffee, but not in integer number.
Super good question. Super good question. And there is a section in my notebook which is called strings. Okay, so all the text goes in quotation marks. So if you want to, for example, you have the variable s, okay, which needs to hold some text. Okay, this is text. All the text goes between quotation mark. For the machine, it's like, when you have, at least me, when I was in primary school, when you had the dialogue things, like me, you always put the text in quotation mark, right? And so for the machine, it's the same. If you put the text in quotation mark, the machine knows, okay, that's gonna be some text. Because if you just write, for example, like this, this is not text. This is gonna be the name of a variable, okay? I know it's super confusing, but the rule is just quotation mark, text that I input, whatever I want. No quotation mark, that is the name of a variable or a function. Like print is the name of a function. Here, this string, I mean this thing is a variable, okay? For example, I can assign the value, again, the value 10. If I print, if I print this is some text, I will get 10. Because here I said to the variable named confusingly, this is some text, put the value 10, okay? Let's cancel that because it's a bit confusing. Let's keep like integer number 10, print the cost of a coffee is whatever, okay? Another question.
Is the space between comma and integer number necessary? Is it important?
This space?
Yes.
Let's try.
Or before 10.
Well, before 10 is more important. Here is not important. Look, you obtain this exact same thing, okay? Before 10, if you cancel that, you're gonna get the 10 that is closer to the string. Because if you do like this, what you're saying is that my string is gonna be the cost of a coffee, colon, space, and that's it. If you do like this, you're gonna say the cost of a coffee, column, nothing. So it's gonna be, I mean, look at the output. Here it's really close, okay? Like this, the 10 is shifted a bit. So it's just a matter of visualization. I wanted to have it a little bit farther from, okay? But no big deal. And within the commands, doesn't matter. You can do like that. The machine is, in that case, flexible enough. Spaces do not really matter. If you go to new line, sometimes it
matters in the name of the variable.
Sorry?
It matters in the name of the variable.
Yeah, I mean, well, you cannot put spaces in the name of a variable. If you do like this, you cannot do it. Look, I mean, you see that those red lines, when you see red in the context of, let's say, of Python, that means that a problem is there, okay? So a variable, the name of a variable needs always to be something like all one block of characters, okay? So usually what computer scientists do is like, okay, I cannot use the space, I put the underscore, yes, and then I can say, okay, go, I wanted to write go. You can assign whatever thing to it, okay? So, incidentally, we have already seen strings and numbers. Now we need to have a look at numbers, okay? So, we have already understood how to define variables, because name of the variable equal something. That's the way one defines a variable. So, for example, I want to define a variable x, which holds the value 10, 5, okay? Be careful, I mean, again, the machine, it's really picky, and if you want decimal numbers, you need to use the dot, okay? Whereas the comma is used for something else, but let's not skip ahead, okay? Let's go step by step. So far, comma is used like in this, where was it? In these cases in which you want to separate blocks, okay? So this comma for separation, dot for decimals, okay? And, well, I told you about types. That's a bit technical, but you need to know at least high level what a type is. So, for example, in this case, look, I define the first variable 10.5, okay? 10.5 is a decimal number, okay? In Python and in many other programming languages, 10.5 is a float. What a float means, I don't know. Float just means, okay, it is decimal. So for you, float equal decimal. Whereas you see here that y, I define it a little bit differently. I said y equal 3. 3 is integer. I mean, it does not have any commas, any stuff. And indeed, if you do type y. Again, Python has this thing that if you want to know the type, if you want to print, just do type, parentheses, and your things, print, parentheses, and your things. And you see that here it's float, here it's integer. Types are different. I know, I mean, probably somebody even may say, but these are data that are not really important. Well, not so much, because sometimes you get really nasty errors that are related to types. So you don't have to know all the types, okay? But you need to know that those exist. For example, we have said that we can say S equal hello, okay? Maybe we can ask ourselves, yeah, but which type is that? I mean, I don't know. Type, we can write it down, type S, type of S. We hit the play button and we see that it's str. I told you, whatever is in quotation marks, that's a string, okay? String is a text, okay? String is just the way Python calls text, okay? And that's important because, for example, you cannot add a string and a number, right? I mean, imagine hello plus 1. What does it mean? It makes no sense, right? So if you see that you have some error related to type, at least you know what a type is. There are different data types. Text is some kind of type. Numbers with commas, okay, so with decimal part are a type. Integers are another, and so on and so forth. So let's try to use Python as a calculator. I mean, it's some people use that as a calculator because, you know, when you have to, I'm not good at doing operation in my head, even if those are sums or so. Imagine you want to, you take a number that is this number, 10,202, and you take another one which is 5, okay? Well, you can say I want the sum of the two numbers, so I want x plus y, okay? And the z, it's a new variable. We can define as many variables we want. We can call it my summation, okay? And so we may say, okay, let's print that the sum of the two variables is my summation. I mean, what are we going to expect? If we hit enter, we are going to have the 2 plus 5, we have a 7, and then the numbers are going to be the same. So you can use it as a calculator, but of course you can do whatever type of operation. So the syntax is a little bit different maybe, but if we want to do subtraction, you can do x minus y, okay? That's the usual thing that one would do. And now let's call my subtraction, difference better. Okay, so my difference is going to be x minus y, and again we can do print and say difference, colon, comma, because, you know, separate things, and here we write my difference. And that's it. You have the difference of the two numbers. You can do all the type of things, so let's do like this. Let's wait, okay. If you want to divide the numbers, okay, of course there is a function to divide the numbers as well. So you take your x, that one is for division. I mean, maybe you have already seen it. I don't know if Excel uses it or INED, but it makes sense, right? It's like something over something else. So x divided by y, and you call it my division. And you can print it. Now let's print it without the text. Let's be lazy, okay? I told you I'm lazy, and that's true. Let's just print it like that. Okay, it got me some decimal number, okay? And that's it. We may use Python as a calculator, and it's easy. We have basically seen all the operations. We miss maybe at least two. If you want to multiply things, okay, let's do my multiplication. And yeah, it's gonna be x asterisk And why? As simple as that. You want to print it. You do print my multiplication and you have it there, okay? And okay, so we have used Python as a calculator. So if you wanted to have a really powerful calculator, now you have it. So whenever you have to multiply, subtract some numbers, I expect you from now on to just use Python. So you open your Jupyter, the Google Colab interface, and you write your equations there, okay? But,
2 questions.
Yes?
What is the benefit of using several of those versus one set?
It's just, in this case, it's just for a, let's say, teaching purpose, to divide things. You can put everything together. So, for example, let's do it. You can put all together and you can run it all together. You're going to have difference, the division, and the multiplication. It's just, Giordano told me to tell you this. Sometimes with Jupyter, with this kind of representation, we lose a little bit the context. So let me explain. Well, this is like a bit difficult to explain, but remember that you are in one environment. So, for example, if I do my difference here, I define my difference here. So my difference is equal x minus y. And then I go here and I do print my difference. The system is able to know that in a cell above I define my difference, and if I hit the play, I get the difference, okay? So the cell are like more of a mental division. For example, how I use them is like I have to do one task. Let's imagine also the machine learning processing pipeline. I have to do data cleaning. Okay, in one cell I do data cleaning. I call it in the beginning data cleaning. I do all my data cleaning, I see that everything makes sense, and that's one cell. And then I do another one. But if you prefer to do all in one big cell, you can do it. If you want to do one line for each cell because you want to, let's say, see how the program is doing, you can do it. Doesn't matter. It's more of a flexibility that you have in saying, okay, I did one thing, I put it aside, I continue to do something else. But remember that the variables that you have defined before are visible everywhere, okay? If you change, for example, my difference here, and you set it to 10, that's going to be equal to 10 in every other cell. So, I know that's confusing, but just be careful that even though the subdivision you can decide, you have the freedom to split your code how you want, remember that machines are really, really picky and are really detail-oriented. If you call something a name, that's going to be wherever true, okay? So we are prone to mess it up. To us, when we are doing our day-to-day work, we always make some mistakes, but yeah, just be aware of that.
So the names are not given. Maybe I can say division equals x minus y, and then it doesn't have to be my difference.
No, you can. You like a division.
So I give the names.
You give the names. You give the names. You have the complete freedom over the names. So you want to do x divided by y and call it division and then print it. You have your division. And if you see, of course, it's the same number that you had before with my division. But the name, it's up to you. The name, usually, in computer science, there is a naming convention. For example, there are people that maybe are even really good at coding, but they put X, Y, W, Z. I did it as well, I did it as well here, but just because those were numbers that we didn't care. Usually, you always use something that has a meaning. So, for example, you are dealing with a piece of text. and that text is your first sample. You call it first text sample. It's gonna have some value. Let's do something that makes no sense, but it's always a good rule to give to a variable a name that if somebody else looks at your code, it's like, okay, probably that's gonna be a text sample. For example, snap. Okay, let's reload the notebook.
So the variable that you declare at any moment is always a global variable, isn't it?
In this case, yes.
And then also, how would you expect that Collab, for example, expects the value of the variables from the user? Like in this case, the programmer is putting the value of the variable. What about if you want to get it from outside?
Later on, but probably 1 hour and a half from now, we are gonna download and load a dataset. It's gonna be a dataset about flowers, okay? But it's a web, a link, okay? So you can take stuff wherever you want. So we are gonna see it, but it's skipping 5 steps ahead. So for the time being and for at least another hour, let's put the value ourselves, but we will be able to load from anywhere.
What is the yellow highlight that sometimes appears?
Well, it's like a warning that tells you you have not given a value to that variable, okay? Indeed, if I do like this and I say, now it's fine, now it's fine, okay? So it's just telling you, hey, you wrote a name that you have never told me what it is. So are you sure you wrote the right name? Because sometimes maybe I make a lot of, I told you, a lot of typos. So maybe sometimes I think that I wrote sample, but I wrote seplo, okay? And then I try to use that thing and it messes it up, but giving you the curly yellow thing really helps you to, let's say, keeping track and not make huge mistakes and just, fix it before the problem comes. I think we can stop here for the coffee and we are gonna resume in 30 minutes, okay? Don't feel ashamed anything. I mean, it's really important that we slowly proceed together and understand the most things together, okay? Okay, so let's go on. And let's talk about comparisons, okay? So we have said, we have understood how to assign some values to a variable. So for example, we can say that our variable that we decided to call x is equal to 10. And we can say that, okay, another variable called y is equal to 6. But what about we would like to compare those numbers? I mean, as somebody asked before, we are putting the number ourselves in, but usually what you do is like, you take some data and the code itself looks at the data. So you don't know in principle if x is bigger than y, smaller than y, and so on. Here, it's a toy example, we already know. So if we say x equal to 10 and y equal to 6, and we want to compare those, okay, let's try to print x greater than y. I mean, 10 is greater than 6. So if we run this cell, we see true. So true, it's a new data type. We were discussing about the types before. This is a Boolean type, true or false. It's pretty important because whenever you have a comparison, whenever you want to have a yes-no answer, okay, then you're gonna have a Boolean. You can do a lot of things because, for example, let's take more of a corner case. So let's say that x is equal to 10 and y is also equal to 10. Okay, so if we say x greater than 10, well, I expect false because x greater than y. I expect false because 10 is not greater than 10. It's equal but not greater, so I see false. But maybe I'm just interested in knowing, okay, is x greater or equal than 10? So, I mean, I know that seems a bit confusing at first, but when you start thinking about that, I want to know if something is greater or equal. Okay, I put the greater sign and the equal sign together, and now, true, okay, because x is equal to 10, so 10 is greater or equal than 10, okay?
Sorry, I understand that, so it takes the last value, because we define x previously to, right? So it's last value.
Very good thing. So, let's do something else. Let's take y, okay? Because here I said that y is equal to 6, but here I said that y is equal to 10. So now y is equal to what? To 6 or to 10? 10. Okay, perfect. Indeed, if you do like this, you see that y is equal to 10. But if I do something like this, so I rerun this cell, and I do like this, now y is equal to what? 10 or 6? 6. And indeed, I mean, order matters. That's something, again, that my colleagues were telling me, is like to tell you that order matters. So if you are defining multiple times the same variable, y, for example, and you mess up the order, so you run first one cell, then the other, then you go back, and so on and so forth, it takes the last value that you assigned, okay? So always be aware of that. How to solve this problem at the root? Whenever you define a variable, take another name, okay? So if you really need a new variable, call it differently. Don't use x, y. We do it today because, I mean, right now it's not really important if it is 10, 6, it's just random number that we are putting in. But it's a good rule of thumb that if you are messing up and you are, redefining many times the same variable, maybe it's time to, okay, let's call it another way, because probably it's some other concept, okay? Thanks for the question. Okay, so here is just a list of other possible yes?
So, thanks for this. This is very useful for when we do objective assessments like this. 10 is greater than 6, that's fine. But we as social scientists, often we face cases when the outcome of interest we are studying is quite subjective, right? For instance, suppose that we are dealing with research on why some military interventions succeed while others fail. And we have 100 cases of military intervention throughout history that we are studying. Now, is Python helpful in deciding, it's a subjective interpretation, whether military intervention X was a success or a failure? Can we use this?
Can you rephrase it? I mean, I didn't get it. You have one, I didn't hear you well as well, sorry. Tell me the question again.
Asking about cases when our outcome of interest is subjective, right? In terms of subjective interpretation. We use, for instance, suppose that we are focusing on a research question, for instance, why do some military interventions succeed while others fail? And we have 100 cases throughout modern history, and can we use Python to help us in assessing, with this degree of subjectivity, whether military intervention X, for instance, was a success or failure?
Okay, short answer is yes. How? Two ways come into my mind, okay? Today, what we are gonna see about Python, it's the basics, okay? Because what you're saying is like something that it's really advanced. So these are like just baby steps of getting to know the language, okay? You don't, if you want to learn German, you don't start from Goethe. You start from how to say, what's your name, right? So this is our what's your name. But to answer your question, at least it comes, two ways of assessing subjective things in my mind. So one is like, assessing the uncertainty, okay? So a model can be really certain of an answer, or a model can be a bit uncertain about an answer, okay? That's a bit, again, advanced and difficult to grasp, but imagine that you want to classify cats and dogs, okay? You have images. That works with text as well. I mean, just to make a simple example, your Python-based machine learning model may tell you that something is a cat with a high confidence. And so you're sure that that's probably it's more objectively a cat. Or it can tell you something with lower confidence. So maybe you can just take the examples in which your pipeline is not confident and you check them manually. I mean, in my view, AI does not substitute the social scientist. In many instances, it tells the social, helps saying, okay, these are simpler examples, I can deal with them. I leave the tough examples to you. Check them. Then make your own subjective or your own interpretation of that, okay? So it's more of a tool of, okay, let's make my life simpler and that's it, okay? Or maybe you may even try to develop models that tell you where to focus. So probably tell you which parts of your textual data are more relevant for what you need to do. And so you focus on those and you make based on, let's say, the outcome of the model is like not telling you the truth, but it's telling you, okay, you have a long thing, just focus on there. And then you, instead of reading the entire text or the entire book or whatever, you just go into those parts and you do your qualitative analysis there, okay? So that those are two ways in which that can help you. But before seeing these things, it's gonna take a couple of days because now it's just, okay, we have numbers that we have put, let's sum them, let's subtract them. It's just to, getting to know the language, okay? But yes, they will help you for sure, okay? Just let's make baby steps to get there. Something else? Somebody want to ask something? Okay, so let's continue with our baby steps, and we have seen how to assign variables, and I told you that you can sum, subtract, and so on and so forth. Here are just other operations. We have seen the sum together, okay? We have seen the division together. This is the integer division, okay? It's just changed a little bit because see, now, okay, let's run it first, okay? So the normal division, if you have 7 and 2 and you divide 7 by 2, you get 3.5, okay? That's, okay, it's something that we know. Sometimes you want an integer division, so you want something that is an integer value. You don't want the point something, okay? So you just do double the slash, and instead of getting 3.5, you get 3. But again, just a detail. You have other operation, the power, the remainder, but let's leave them there, okay? It's not very important. What is important is that the equal operator tells you if something is equal to something else, okay? Because the equal operator, we already used it. So remember, when you have x and you want to assign a value, okay, you use equal. So x equal 1. If you want to see whether, I don't know, x. You have this x and y, and you do like this. If you want to see if two variables are the same, you cannot use the equal, okay? Because the equal has already the purpose of telling you, okay, I take this value and I put it in this variable. So if you want to see whether x is really equal to y, you do the equal, okay? But with this is a warning, but it's pretty important. It's a detail, but if you fall for this, it's a problem. So when you are working with numbers with decimal part, okay, there's always an underneath representation. So the computer needs to represent somehow that value. And if you take 0.1 and you sum it to 0.2, okay, and then you do, is the sum equal to 0.3? So we have just seen the equal operator, so we sum 0.1 plus 0.2 equal 0.3, but, well, we expect to say, yes, it needs to be true, right? Okay, that's not the case, okay? That's false. Why? Look here. I mean, you see that 0.1 plus 0.2 is equal to almost 0.3. Is 0.30000000004, okay? That's the internal representation. I mean, you cannot represent the numbers perfectly. The integer, yes. So the integer, no problem. So 1 is equal to 1, yes. But when you are with decimal, you need to really be careful, okay? So there are methods that help you. This is just a warning, okay? Put it on the back of your head, forget it for the time being, but be careful when you have numbers that are like 0 point or 1 point something. You cannot do all the things as you expect. And that is due to the internal representation. Really technical things. Just know that you need to be careful, okay? So let's move to something that is more comprehensible, okay? We have already talked about strings because we have been printing hello, we have been printing today I will learn Python, and I told you that to define a string you have to use the quotes, so double quote, and whatever you want to put in, okay? And so this is your string, a string, you call it without a lot of fantasy, you call it a string, and you can print it, and again, if you run this code, you print your string, okay? I want to tell you a little bit more about the representation. Whenever you're a string, I mean, you know that's made up of characters. So you can think that at position 0, you have the H, then you have the E, L, and then the O. So you can see the string as a collection of letters. I mean, that's normal. When you write down something, you write it one letter at a time. That's important because you may want to take a piece of the string. So let's imagine that I want to take this part, okay? For some reason, I don't want the entire string. I just want to isolate the E, the L, and the L, okay? That's called indexing. Let's try to do it, okay? So we do it here. And to index a string, the syntax is like you open the square bracket, you write the index you want to start from. So I want to take the characters from the first position till the fourth, but without taking the first. So let's say the second end is always excluded, but you just write like that, and if you do like this, the extracted substring is ELL. Let's imagine that you want to take one letter less. So you want to arrive till here. Instead of writing 4 there, you put 3, okay? And not surprisingly, you get EL, okay? I mean, that seems not necessary, but it's always the case that you want to take pieces of your string. So let's imagine that you want just to isolate the first character, okay? As I wrote here, computer scientists like to start counting from 0. So the first element is not 1. You don't start 1, 2, 3. You start 0, 1, 2, 3, 4, okay? So if you want to extract the first character from the string, this hello string, you need to say the name of your variable, which is a string, and you say square brackets, 0, so I want to take the 0th element, and you print it, okay? So let's remove the second line. In this way, you are able to take the first element of the string. There's a cool way of taking the last element of the string. So we have seen that, I mean, you start counting from 0, but then you have 0, 1, 2, 3, 4, and so on. So a negative value does not make a sense, right? Because how can you define a negative thing? Well, there's this cool trick that if you want to take the last element, you put -1. So if you put -1 and you run it, you get the O, okay? So it's just a way of saying, if you put the minus, you start from the end, okay? So, I mean, there are I know that it's super confusing the first time that you see all of this, but start playing around. I mean, let's imagine we want to take the H and the E, the first two things. We have seen that the syntax is like our substring. Just taking H and E means I need to start from 0, and I want to take up to 2 excluded. Okay? So like that, I'm gonna take H and E. This is called substring. It's called indexing. Okay? You take substring, portion of your string. Imagine you have a long text. Okay? Many times you just want maybe to focus on the first 100 characters. You don't want all of it. So you just do from 0 till 101. I mean, in this case, we just have a low, so it's not that long, but it's important for these kind of situations, okay? So we have seen all of it. Again, just remember that the syntax is you take the name of your variable, you take the starting index, colon, and you take the ending index plus 1, okay? And you can do very different things with this kind of syntax. So I told you that the negative numbers hold like a completely different meaning. So I told you that if you start from 0, you go till the end, and you apply -1. Now, okay, then you are. I lost the string. Let's call it again. We had a string that was just hello, okay? If you do like this, you revert the order of the string. So you say, basically, when you don't put anything, you see that there's anything, colon, -1, you say, let's start from the beginning, let's go till the end, and let's take the opposite direction. So you just read it backwards, okay? These kind of things may be confusing. You will see them 3-4 times and then you will get it for sure. I'm pretty sure I lost 80% of you, so just ask me questions.
Can we go back to the first character in the string and how you wrote that, because I got that wrong for some reason.
Okay, so you want to extract the first character, right?
Okay.
So let's, just to be sure, write down our A string. So let's take the variable, let's assign it our hello, and let's look at the diagram there, right? We say that a string is a collection of characters, and the first character has ID 0. So we just say, okay, square bracket 0, and if we do like that, we get our first character. Yes. Still getting the error, or does it work?
Let me try. Okay, I think I got it right, yeah.
Okay. Then again, if you want to get not only one, but you want to get more, so you want to go one character farther, you do the column and you say 2, for example, and you get HE. If you put there 3, you got HEL, and so on until, at some point you finish the hello, but you can take portion of your string. Thanks for the question. Yes?
How can I take just, for example, the first one and the third one?
Okay, so the first and the third, you can do it in this way. Wait.
I think you just have to sum them.
No, puoi fare fancy indexing, no? O solo con le... Ok, so you're gonna do like this. This is a way of doing it. But
what if you want the odd position?
That's a good question, and that is something that you can do easily, because you can do like this. You say that you take your string, square parentheses, and you say, okay, start from the beginning, so you don't put anything, column, arrive till the end, column, and you say 2. That means make a step of 2. So if we do like this, of course, you start from 1, so you take the odd and not the even position. I mean, you just jump. If you see here, let's do like this. Here I say, I start from the H, I skip the E, I take the L, I skip the other L, and I take the O, okay? Of course, if I offset it and I say, okay, let's start from the E, you take the E, I mean, you neglect the H, you take the E, you skip the L, and you take the other L, okay? So with this kind of syntax, you're doing, you know, jumps. You can do jumps of 3 or whatever, okay? Odd enough? It's okay? Okay. Okay, so some functions. I told you a lot about, we spoke a lot about functions, right? And I told you that many times somebody else wrote some functions for you, okay? So you don't have to implement them. So let's take another string, okay? Here I called this new variable another string, and equal hello. Here you have the capital H, then you have the E, and you have again capital, and the O it's lower. I mean, it's messed up. It's better to have either everything capital or everything lowercase. But I mean, if you want to make it lowercase, you can do something very simple. You take the name of your variable, okay? So another string, you do this kind of dot operation. So you put a dot and you say, you invoke the function. So this is a function, is the lower function, and you call it on your string, okay? And you can see that if I run it, I mean, you started, let's even print the starting string, okay? So let's do print, you started from, and you're gonna see hello like that.
It will still because you made it after the lower.
Sorry. Thank you so much. So you print it right after you declare it, so you have it right. And you see that you started from the string that you define, in which you had like uppercase, lower, upper, lower, okay? And this function, which is dot lower, already does everything inside. You just need to know, okay, I want to get all my text in lowercase, and it does like that, okay? So you get your text in lowercase. And there are a lot of these kind of function. There is the replace function, okay? So let's look at it, because sometimes you want to replace some parts of your string. So let's declare it again, another string, and let's do, okay, hello, okay? It has a double L. So imagine that for some reason, that double L, you want to become a single L, okay? So you can use this function that is called replace, and what you do is that you take your variable, okay? You do again this dot and function. So, I mean, you can think it this way. If you have a variable and you want to call a function on the variable, you can do name of the variable, dot, and the name of the function. So here, it's like in English. You want to replace the double L with a single L, okay? And so you do your variable dot replace the double L with a single L, okay? And you see that, I mean, indeed, you got hello, okay?
Does this replace function start from the beginning until it finds the first double L? Because what if you have triple L in the hello? So does it really look at the first two double L's, change it, and then we'll look at the...
It does change the first instance. If you have like, I mean, it matches the pattern. If you have the pattern multiple times, like here, you have 3L, but what really happens is that you have these two L's, and those get substituted with one. Then you have another L, and that remains there. And then at the end, you have again double L, and those get substituted with one L. Okay? So it replaces what finds in the string.
In
Yes.
practice, how do people know about the there are a limited number of actually normalized.
In the old times, you had, for example, we will see some libraries. You know, I told you that there are these libraries. So in the old times, you had the documentation of these libraries, kind of, you know, online, of course, but you had all the functions that were implemented by the libraries. But now, what you can really do is like all these things. If you need to transform all your text to lowercase, you can ask Gemini and you say, how can I make all my text lowercase? And Gemini will tell you, hey, there is the lower function, and you can apply this, and I mean, it even tells you how to apply it. Here, I mean, I try to tell you just, you know, to get the idea, because what I see even from computer science students is that if you start right away from AI and you rely too much, I mean, in some sense, AI knows more than me, more than you, more than anyone, in some sense. And you just take it for granted. But if you see the ideas, the complexity, then you can use AI in an informed way. So after today, you already know that if you want to do lowercase, you have your variable, you do the dot, and then you apply lower, and you already have an idea of how it works. So when AI tells you what to do, you say, okay, I remember that at the winter school I saw that. Okay, so this more or less makes sense. Let's try. And you know how to try as well. So you change the things, you try to play, you see the results, you see if everything makes sense. It's more of the process rather than the things. Today I will not tell you all the functions that exist. That's, I mean, probably it's already a bit boring compared to the first part of introduction, but you know, programming, it's a little bit boring. It's fun when you know it, but when you have to learn it, it's like, I have to know all these details, the dot, the thing, the variable, then, oh my God. It's a bit boring, but it's necessary. I mean, it's a little bit necessary to try to follow a little bit, and then, okay, when I have the ideas, then I can go on from there, okay? So we still have 1 hour. Let's try to see something more advanced little by little. I'm gonna show you how to use the libraries, and those gonna make something more powerful very simply, okay? So that's gonna be maybe more interesting than, you know, taking pieces of strings, but the ideas of the fact that you can take some pieces, how the data are represented and so on, especially if those are new concepts, are really important. So let's keep it up. I mean, we arrived so far, let's do a little bit more work together, and I'm sure that you will be bored, but you got some new concepts, okay? Okay, so yeah, I will skip this example. It's not very interesting because I want you to do some very basic exercise. So what I want to do is like, given two numbers, 8 and 5, subtract them and then print the square of the difference. This is the first assignment. Try to do it and then I tell you how to do. Try to do it yourself. I will for sure tell you one of the solution, but I want you to try to do it yourself. So you have 8 and 5, how to do? You want to take the difference and then you want to make it square, okay? So I'll give you 5 minutes, 6 minutes, 10 minutes, okay? When I see that you are looking back at me, we will start again, okay? Of course you can ask questions in the meanwhile. Nice.
The second exercise, thank you.
You want to start it again already?
I didn't do the second one.
Yeah, but I mean, that's fine. Let's do the first one, and when we are all done, I did like this not to make you think that you needed to do both. Let's do the first one, and then let's do the second one later. So, yes, no, sorry. I thought you wanted to ask something. Okay, can we sit together? Still a little bit of time? I don't see a feedback from you, so okay, we can go. Somebody tells me that we can go, and
I said I need some time.
Sorry. Okay, so let's wait a few minutes more. It's important that you try to do it, and then we see it together.
I've done it with two methods.
Sorry?
I've done it using two methods.
Okay, perfect. Okay, not to pressure you, but in 1 minute I will spoil you the result, okay? Doesn't matter, I mean, if you got it right or not, it doesn't matter. The important thing is that you tried, and the process of trying to understanding how to do it is valuable. Then I can even spoil you the result, but I mean, it's all about the process, okay? Okay, I'll show you, and this is not the only way of doing it. I mean, there are two ways at least, probably even more, but let's start from the beginning. So I told you that we have two numbers. We have learned together that if you want to assign to a variable the value 8, you just do number 1. You can use x, you can use whatever name you want. Number 1 is equal to 8. Number 2 is equal to 5. Then we gotta take the difference, so we take number 1 minus number 2. And we put it in another variable that is indeed difference. But then I told you, okay, we want the square of that. And I was not a really good person here because I did not tell you explicitly how to square, because you see, this is the first way that I used, is diff asterisk asterisk 2. That means your difference by the power of 2. But you could have done simply diff times diff, okay? So if you just multiply the two variables, you can do it, and you get, of course, the same result, okay? Did you get it right? Did you struggle in some places?
I think I did something mistake, like I put diff in the end, and it didn't work. I don't know why.
In which end?
Diff. I did num1 minus num2 equal to diff, and it didn't work. Like,
yeah, Andrea will help you out.
I actually did. I gave the difference a different value, so I named it z, and I did z asterisk asterisk 2.
Perfect. Yes, that's nice. I mean, that's the first, let's say, sensible program that you wrote. So that's super good. Okay. That's really good progress, and it's gonna be easier from here, because then, I mean, many times the variable is not asterisk asterisk. I mean, asterisk asterisk is not a good way of calling something. You know, it's the old style computer science way. But when you're gonna use functions, the function is gonna have a reasonable name, like print. You know, print. Okay, it's gonna be printing, so it makes more sense.
I use the function called far.
Yeah, that's perfectly fine. Yeah. I didn't want to use function because then I needed to introduce like a step more, but perfectly fine.
Search by putting a dot, you get the.
Yeah, you get the suggestion of all the functions that are in the standard library. I saw another hand rising before. Do you maybe want to tell me something? No? Yes?
In the beginning, I tried it a little bit differently. I wrote I defined the first two numbers, but then I wanted to do print, and then the difference, and then the function of the difference. But I didn't know how to use the result of that to make the square of the result.
Okay, so yeah, I think I understood. Then, if I tell you something that it's not the answer that you were looking for, please tell me, and I will try. But if I understood well, you wanted to do something like this: the difference, and maybe do num1 minus num2, so you can print the difference. And then you wanted somehow that thing to be to the power of. Well, here you have just two ways of doing it. The first one is to say, okay, the square is, okay, and what you need to do is repeat that, okay? So you repeat that, you need to put it between parentheses, and that's like something really important, because, you know, the operations have an order. So you need to put that between parentheses, and you shall get the same result. Oh, I got an error where? num1 is not defined. How is not one? Let's do like this.
You can use Gemini to explain the error.
You can use Gemini, but let's redefine the numbers. Okay, so for some reason, you know, sometimes it disconnects, and even though you have the number there, then the cell does not run. So one way, as your colleagues were suggesting, is like use Gemini to get your, let's say, your error analyzed, or if you know that you add the variable and for some reason it disappears, you can just put the variable there. But you raised a really good point, because you can do this way, but you need parentheses, or, and it's more similar to what we have done, it's like you call z the difference, okay, so z or whatever, you can call it difference. You put that intermediate result into a variable, and so that you can then do like this, print, I'm just gonna copy paste, and you're gonna put z there, and then you're gonna say, okay, and the square is, and you're gonna do z, okay, and like that it works as well. But you know, if you make an operation like a subtraction, either you print it right away, or you need to put it like in a temporary variable. So you put it there and you reuse that. But let's say you cannot do this operation and not assigning it to something. Either you redo it, okay, because basically here you are redoing it, or you save it somewhere, you put it there, and then you use it again. Thank you very much for the question. That's a good point. Yes?
Regarding the error, do we have to save what we have done manually from time to time?
An
error that num1 was not defined?
No. This is something that also Giordano was mentioning. For example, if we are here and then we go for the coffee break, it somehow disconnects, and so all the variables that you have defined, get erased, but not your code. So you just need to rerun it. So you go on the block before, you do play again, or you have this button here that is run all. So for example, we have been working for an hour and something. We have been assigning all our variables. Then we go to talk to a friend. We come back. It refreshed somehow, like the browser. It just raised all the variables, but you play run all and you start again fresh. So that's another way of doing it, okay? Some other curiosity, something else? Did you succeed it? Because now there is point 2. We need to work with string now. So the second exercise, it's gonna be needing do you remember the replace function that we just seen? So I want you to take the string, today I will not learn Python, and I want you to substitute the not with an empty string, okay? Hint, empty, if you do column, nothing column, that's an empty string. So try to replace the not with an empty string, okay? So try to do it, and of course, as always, we see it together. Give it a shot. I give you again a few minutes to do it.
ممكن نستخدم براكت العادي كله؟ لا لازم
Okay, so 1 minute and a half and then we look at it together, okay? Just try to give a last go and in case we see it together, okay? Okay, can we look at it together? Okay, so I will tell you So the second exercise you can do like this. You have the string, today I will not learn Python. So you have this string, you assign it to a variable. We can, I mean, I told you to call it in another way, but we can reuse a name that we already used. And then you do a string dot replace, and you just say, I want to replace the not, okay, with the double quotes. Okay, this means an empty string. And I mean, beware, here I did a little, not trick, but like I was a little bit careful because I put not and a space, okay? Because if I just put not, I get one space more. I mean, it doesn't really matter, but you know, if you just do not and the space, then you're gonna have, you know, just one space between your words. So it's just one of the, it's replace function in action, okay? Anything that was difficult or made you struggle while you were trying it? Do you want to ask something? Yes?
If we're doing it with numbers, because that's how we taught us to letter the letters have numbers, right? If we were to follow a string and then the brackets where we put numbers, how can we do that?
Okay, that's another way of doing it. Yeah, well, so.
You can't do 12 to 16, but there's a point, there's a catch here with the word not.
So I will. So this is another way of doing it, but you should count more, so it's a bit more difficult, but I mean not difficult, it just takes a little bit more time, but if you want, as your colleague was pointing out, you can say, okay, I'm gonna take the my original string, which is today I will not learn Python, and what I can do is like, I start from here, I arrive till here, and then I stop. And then I start from here and arrive till the end. So you just gotta, you know, 0, 1, 2 count. And as your other colleague told me the exact numbers, you can do like this. So you take the string, you take the first part, okay, and then you use the plus. The plus, it's really versatile in Python because it allows you to put together things. So if you have numbers, you do 1 plus 2 is 3. But if you have strings, you are basically gluing them together. So you take the first part, you glue it, and you just skip the not that you didn't want to take, and that works as well.
There's a catch with what you said there, because when you say today I will not learn Python, what if you have a statement saying today I will not learn Python with note? If you say with note, and then you say replace not, it will replace this not and the note.
Yes, and that's for sure.
And only keep for you the E at the end.
That's for sure.
What you want.
Yeah.
To remove the not in the middle.
So
therefore, in this case, the other one would be a better option if you have the not appearing for certain words.
Well, depends. I mean, here is just an example. Usually when you want to replace something, you typically want to replace all the instances. So for example, you have hashtag ID 1234, which...
Yeah, but the point is, what if you have the word noteworthy?
No.
Noteworthy is not.
That for sure, but I mean, usually when you do these kind of things, you know that you have a placeholder that's unique. Maybe you have just, you know, a very long alphanumerical thing that, of course, it's very unlikely that you're gonna use that string for text, okay, and you want to replace that with something else. Of course, as your friend was noting, is like, let's make that example because it's, I mean, he's perfectly right. So imagine that you have, that is not what I asked you, I mean, it was not the task, but imagine that you have, today I will not learn Python from no, okay, like that. If you if you replace, and you replace not with empty, as your friend was pointing out, even this part will be changed, and is not really what you want. So, I mean, you lose that not. So for sure, this was just, to let you understand the function, but as always, if you know what's going on, you know what you need to do, okay? So, very, very nice observation. Yes?
When you are counting the strings and trying to rearrange the order, does space also count there?
Yes.
You have to count the
Yes.
space as well.
I mean, nothing is something, okay? So a space is like...
So like when we start from 0, 1, 2, 3, 4, 5, and the space is also a number.
Sure, sure. Everything, even nothing, it's... I mean, if you have a gap, let's say, even though if it's just a space, that's a character, yeah.
Can you go back? Yeah, so last one, a string from 0 to 12 plus a string from 16. So what does 16 represent there?
It's just the position. It's just the position that probably is there, okay? You just skip the not.
Which includes the spaces as well.
Yes, you count, so this is gonna be the, I remember you start counting from 0, not starting from 1. So computer scientists like to start counting from 0. So this is gonna be 0, this is gonna be 1, this is gonna be 2, and so on and so forth, okay? Yes?
So you said that you also are looking for shortcuts. So is it too wrong if we just do a string today? I will not learn the Python, and below print, open the bracket today I will not, quotation marks, without space, learn Python, and then again we will get it today I will not learn Python.
Well, that's too lazy. Yes, that's too lazy, because yeah, it works, but the task was substitute. So the task was you needed to substitute it. So you needed to use replace in that case. But I mean, as we were discussing, even if you took the pieces and glued together was good, but just printing it was not that good, let's say. Okay, can we move on? We have some other things to cover. Okay, so we have already looked at collections of data in some sense, because I mean, I spent so much time on strings, not because I'm passionate about strings, in some sense because it's really important since we are dealing with text. So text is a string, but also because it's like a really good starting point to understand collections, okay? So hello, it's a collection of characters. You have the H, the E, L, L, O, okay? Those are characters. And we have seen how to access the characters. We have been manipulating strings basically all afternoon. You know how to take the first character, how to take pieces, how to skip things, and so on. But, I mean, those are not the only collection that we might be interested in, right? So, usually we may have questionnaires, okay, and we may have many respondents to our questionnaire, or we are measuring something, okay, and we have many values. We want a way to put them all together in a reasonable way, okay? And for example, let's make a concrete example, right? We may want to have some, let's say, personal information. Maybe we want the age, maybe we want the gender and the income, but we want to have the ensemble, okay? We want to put them together and represent, again, in this machine in some reasonable sense. So let's see at collection. We are going to see 3 types of collection. If you don't get 100% those, don't worry, because tomorrow, I mean, you will take again those things, because repeating these kind of concepts will really help consolidate them in your mind. But let's start seeing some example, why you use one, why the other, and so on and so forth. So let's start with tuples, okay? Tuples is the name of the first collection. But, I mean, it's nothing very difficult, okay? So the tuple is like, you open the square parentheses, and you say element 1, comma, we have said already that the comma is used to separate things. So you have one element, you separate it, but you still put it like in the same collection. You put element 2, comma, element 3, and so on and so forth. Okay, what does it mean? For example, an example of a tuple is a person. We may be Alice, we may have Alice, okay, that's a string. You see that is the name of somebody probably. And maybe then you have the age information. And where does Alice come from? Maybe Alice comes from Italy, okay? So you want to bundle this kind of information together, okay? Because we have just understood, okay, I have X equal Italy, X equal 34. Yeah, but I mean, I want them together. It makes more sense, no? If I want to describe a person, for example. So here, you can do like this. You do person, okay? That's gonna be your person variable. You see, you put equal, always the equal to assign things, and then you use this new notation with parentheses. So when you use parentheses, you are making a bundle. In this case, a tuple, okay? And so you just write down Alice, 34, and Italy, okay? And what if we're trying to print it? So we print our let's say bundle, our collection of information, and you can see here that we have Alice, comma, 34, comma, Italy. As simple as that. You are just putting together things. The only thing that is different is that you have open parentheses, something, comma, something else, comma, something else, close parentheses, okay? And if you want, yes?
Why don't we have quotation marks on 34?
Because 34 is a number in this case. So numbers do not need the quotation marks. Whereas you can put the quotation marks, but now that is not anymore a number. That's a string. I mean, you can write 34 in your text, right? You can say, I am Franco, I am 34 in a text, and that's a text. But be careful, because then with that 34, you cannot add it. If you want to do 34 plus 2, that needs to be a number. So it depends on what you need. It's perfectly fine to do like this. See? The code does not break, but you see that there you have the quotation as well. So that's not a number any longer, okay? It's a string. So in this example, we just want it to be a number, but good observation. And what really means is that we have created an ensemble of things, where the first one is the name, the second one is the age, and the third one is the country. So how do we take the first, let's say the first information, or the last one? So let's do like this, let's do it together. How can I take from person the name? Do you have any idea?
I think with square brackets, 0.
Square brackets, 0, and we get Alice. I mean, it's like strings. We have just seen strings are like a collection of characters. Here we have a collection of something that is more complicated but more interesting, because maybe you have a bunch of persons with with many characteristics. You have the age, you have the income, you have many stuff, and you can put them together. But that boring things of strings, the index, the square brackets, take this, take that, it's useful. Why? I want the name and I want the age. We have seen it already. Colon and 2, I take the first two information. So I take Alice and I take the age. Same as string. I mean, these ideas keep coming and coming. It's very boring the first time, but then if you keep seeing them, oh, that's gonna be a breeze, okay? It will come naturally in some way. And we will see that even the other collection are very similar. So, I mean, boring the first time, the second time it's like, I know it already, and the third time is gonna be, okay, I know it. So let's just keep it up, okay? Any question? Yes?
I tried to do this, but I got AL, not Alice 34. So how does that happen?
Because probably you did something like this. If you do like this, you get AL. I mean, if you take person 0, you take just Alice, okay? So you are taking the name, look. If I do person 0, we have seen that I get Alice, okay? But remember, that Alice is still a string, and we have seen that if we do to a string, like take from 0 to second position, we take the first 2 characters. So like that you take AL, okay? I mean, this is like indexing over indexing, okay? It's not clear, right? Or yes? If I hear, okay, I see somebody do like that. If somebody does like that, I will repeat. Okay. And I mean, again, here I'm just repeating. We have done it together. I think it's better to do it like in an interactive manner. But so if you do person and you say, I want the second position, so remember, starting counting from 0. So 0, 1, 2. So you are getting the third element. The third element was Italy, so the country where Alice come from. So if you run that, you have, okay, Alice come from Italy. And that's it. You can assign that to a variable, or if you prefer, of course, you can even print it right away. Why not? You get the same result. You access that information, okay? And that is a bundle of things. Now, that's another example, but here it's something pretty, yes.
In case of, like, for example, how does this indexing happen? I didn't know.
In case of what?
Like we said hello, so in that case the indexing was particularly with respect to the letters. Here we are seeing the indexing is happening with respect to words, Alice, Italy, and so how does this
I mean,
happen and how does it happen?
That makes sense as a question completely. So let's open a little code thing. So string are a special case, okay? Because when you have a string, you are basically already saying that each element, so hello, it's a small piece, okay? So this is like how it is. In other programming language, you do it slightly different, and maybe it feels more like characters. But here it comes down to how the information is encoded inside the PC. So you basically, when you have a string, actually what you're representing is you're representing each character. There is a way representing the character, but let's say the basic element is the character. So this is like first character, second character, and so on and so forth. But it's confusing because there's no comma, right? I mean, this tuple, I put the commas. So you can do something, but it's completely different because it's not anymore it's not anymore a string, but you may do like this. H, comma, A, comma. Oh, yeah. But if I print this, I don't get hello. Okay? Look, if I print this, I get a tuple, okay? So this is a list of strings. I mean, it's a tuple of strings. It may be confusing. I mean, it may be a little bit strange, but let's just take it for granted that when you have a string, that is a collection of characters, okay? And so the indexing is implicit somehow. When you're defining things, like here in the case of Alice, where is it? You basically tell the machine, I want that the first element to be Alice, which is a string, comma. The second element, I want it to be 34, comma. And then I want Italy, closed, okay? So it makes sense a lot as a question. It's maybe a little bit confusing, but now that we know, maybe we start, taking it and going on with it, even though it's a bit confusing, okay? Any other question, doubt, or curiosity? Okay, so let's go to a caveat, okay? But it's a pretty important one. So we have our person. Let's just recall it for person. We have Alice. Alice is 34 and she comes from Italy, okay? But let's imagine that we mess up. I mean, we were at the reception, we wrote the name, but we understood Alice, but actually she's Jada. So we would like to change the name, no? And we said that we can say, okay, if I access in the first position, I can get the name, right? But if I try to substitute it with a new one, I get an error. I mean, this one, it's gonna always give you an error, okay? And why I tell you that? Because there is another collection which allows you to do this, okay? Tuples are meant to be immutable, they don't change. You define it, and that needs to stay like that, okay? And that's helpful, because imagine that maybe you want to write a code in which you have those tuples, and you don't want by accident to change the values in there, because those are really important things and needs to stay that way. Use a tuple, you are really confident that those won't be changed. Whereas, if you use lists, okay, lists are, let's say, flexible collection. Why? Because with lists, you can change the stuff that you have inside. So, let's look at it, okay? So, we do the exact same thing, but, careful, here, we don't have the parentheses, we have the squared one, okay? Again, it's a detail. I mean, machines really like details, so this kind of syntax is completely different than before. Before we had a tuple, it cannot be changed. Here, we have a list, and lists are the most important, probably, collection type of things that you will see, because you will always be using lists. Imagine you have many respondents for a questionnaire, okay? Okay, all the responses are a list of texts, okay? Or like here, you have a person which has name, age, and country, or whatever kind of features, characteristics, and you have a list. So you define it, and you get Alice, 34, Italy. Okay? But I told you, these are useful. Why? Because imagine that you misunderstood the name. So you know that this person, it's Jada, it's not Alice. So you access the first element, which is that about the name, and you say, okay, now I do Jada, and I print it. What do you expect? To break it? Before we got an error, we couldn't do it. Now, yeah, I told you we can do it, so let's hope we can do it. We can do it. I mean, sometimes you need that flexibility. Sometimes you want your data to stay as they are. So you had Alice, 34, in Italy. You don't want by accident with your code to infect those data. But sometimes you want to change. I mean, I made a mistake. I want to put Jada there. You can do it with lists, okay? Okay? Yes?
Can you say the difference between this and tuples, list and tuples? I couldn't understand.
Yeah. So let's open some code. And, okay, there. So, person, tuple, okay? We have said that we need, first of all, brackets, okay? No square parentheses. And you can say, Alice, 34, Italy. So the first difference is how you declare them, because here, if you want to do person list, you need square brackets. So that's, let's say, the first visual difference, okay? And you do, I mean, I'm gonna copy paste. And you can do like this, but one thing that you can do with list is that you take the list, you want to modify the first element, so you want to say, I don't have Jada any longer, I don't have Alice any longer, I have Jada, so you do like this. Okay, you can do it. And let's just check what inside person, so let's take person list, let's do print, and let's print it. We have Jada, 34, Italy. Let's try to do the same thing with tuples, okay? We have the tuple, person tuple there. I want to do the same thing, why not? 0 equal, it breaks, because tuple object does not support item assignment. You cannot assign a new value, those need to stay as they are. It's like all the cases in which you don't want to poison your data and you want them to stay like that, use a tuple, okay? Yes?
Let's say for any reason we want to change the tuple. Maybe we made a typo, we wrote something wrong. Then we have to rewrite the entire tuple, like deleting the previous one and writing the new one.
Yeah.
Or is there any other thing we can do?
You need to reassign it.
Completely
Yeah, but
the previous one and rewrite a new one.
as I can tell you, most of the time you're gonna use lists.
Okay.
I mean,
Just asking for
yeah, usually it's like, it's the most flexible way of doing that, and you will either use lists or dictionaries, okay? Dictionaries is what we are gonna see now, which is like slightly more complicated, but way more interesting in some way. So I will ask you if there are any other questions, otherwise I'll tell you about dictionaries, okay? I will just leave it there, okay? I'll go back later, but I want to I want to tell you about dictionaries also because I think we are almost done, but again, tomorrow it's gonna be a full Python day, so today is just, you know, getting to speak the language, getting the first sentences, that's important, and I really appreciate that you were, I mean, all of you really tried to do. I'm really happy about that, okay? So the first step is the most difficult one. From now on, we can go, I mean, a long way together. So let's understand dictionaries, and let's still keep, let's slightly change the example, then I will go back to the example. So a dictionary is, again, a collection, but it's not just, you know, putting one thing, another one, it's like, you know, enumerating things. Sometimes you want to have a relation between your stuff, right? So think of the case in which you have animals and you want to associate them with the fact they are wild animals or they are pet. So you may want to say, okay, a lion is a wild animal, whereas a dog is a pet. A cat is a pet, okay? So you have a new syntax. You see here, you have dictionary. Now how we have been using all the possible brackets that were available, the parentheses, square brackets, and now curly braces, okay? So you take those and you put your first element, colon, second element, okay? I know it's not clear, so there's like a pictorial representation. You want to make association, so the association is gonna be lion, wild, dog, pet, okay? Cat, pet. Let's go back to the Alice case. I told you that for Alice, so let's make some comment. We had the name, that was Alice, right? We had the age, that was 34, and we had the country, that was Italy. Yeah, but we didn't have that information. I told you that the first one was a name, the second one was the age, and the third one was the country, right? Now, what we can do with dictionaries is like, okay, we have Alice dictionary, okay, curly braces, okay, then you can go to new line just to have a, let's say, better look at what's going on, and basically you do what we have just done, okay? So remember, you have a string, so string always goes in quotes, colon, Alice. And that tells you, okay, the name is Alice. Then you want the age, and you say 34. We keep 44 as a number because we want it a number. And then we do country, and we say Italy. Okay? Okay, so let's try to print it. Let's print it. Alice dictionary. And we can see that that works, and that shows us name, Alice, age, 34, country, Italy. That's already a bit interesting, but what's more interesting is that now before to access the name we were doing name 0, 1, 2. It's tough. I want to speak to the machine. I don't want to put numbers. Dictionary allowed you to do that. So imagine from Alice, I want to know the age. So square brackets, as always. But this time, I say, I want the age. 34. So, dictionaries allow you to have association. You can say whatever. You want the country of your person, so you take Alice dictionary, you do country, and you have Italy. I started from the strings, then the tuples, then the list, and now the dictionaries, just to, make you understand that there are many ways of representing your data. Lists and dictionary are vital. So, but to come here to this, we have traveled a long way. It has been not that easy so far, okay? But this is how you represent data, okay? So, again, this seems not a big deal of work, but we have done a lot today. You have been developing the first lines of code. You understand how to speak with the machine, how many ways are to say the same thing. Like, we have been talking about Alice, the age and the country for, almost an hour, but you have seen that every representation has some differences, okay? And now you know how to do some basic things. You know how to replace strings, you know how to represent some data, and I think it's a really good starting point, okay? Do you have questions? Do you want to know something more? Yes, please.
Will these things receive us? Could we take these workings?
The code?
Yeah.
Sure, the slides and the code, I'll create a folder and then we will coordinate to share it with you. Yeah. You're gonna have all the slides, all the code. I clean it up. I will clean the parts that I have been doing interactively with you, so you have like all the code. And as I know, this is like basic code to get, to learn the language. But the other colleagues have done kind of the same, but with much, let's say, technical code. And that code, you can use it yourself. You have already somebody that wrote that code for you. So maybe you can directly use it. And that's going to be something interesting. So all the things that we show you, that we'll present to you, are going to go directly to you. And you can use it however you want. Okay? So we are almost done. I'm more than happy to take some questions. Okay, it seems no question, so thanks so much for listening, and let's see each other later.
We have just an announcement. You can check your email. We sent an announcement to you. Just for today, we changed the program a bit. Instead of waiting until the 9, today we will make our group